Now, if you were to check out the Sahara from space right now, instead of a barren wasteland, you'd spot a surprising sight. Dry land sprinkled with some lakes and rivers in Morocco and Algeria, all thanks to some heavy rains in early September 2024. These aren't oases. This is just the Sahara going back to the factory settings. Believe it or not, eons ago, one of the biggest deserts on Earth was actually a lush paradise full of greenery. Let's first see how the Sahara turned into a desert. During the last ice age, Earth was much colder, and big ice sheets covered a lot of the land. At that time, the Sahara Desert was significantly bigger than it is today, and on our planet there were fewer tropical forests, and the cooler temperatures changed how rain was distributed in the tropics. Now, normally, warm air rises in the tropics, which helps create rain. Since it was colder during the Ice Age, this system got, well, messed up, and less rain fell in some areas. This caused more dry and desert-like conditions in places that are usually wetter. There was also a lot of dust blowing around in the Sahara Desert, which scientists found in old ocean sediments. But about 12,500 years ago, something surprising happened. The dust levels went way down. This meant that the Sahara got a lot wetter, which is a sign that the climate suddenly warmed up for a while before cooling down again. After 12,500 years ago, the Sahara became a much greener place, like a savanna, because a weather pattern called the Intertropical Convergence Zone, a mouthful indeed, moved north during summer. This wet period was at its best around 4,000 years ago, when temperatures were a bit warmer than today. At that time, more rain fell in the Ethiopian highlands, which made the Nile River carry more sediment. However, there was another big change called a Heinrich event, which caused the Intertropical Convergence Zone to move back south. This led to the Sahara and Arabian regions drying out quickly. Because of this, the Nile River had much less flooding between 2700 and 2100 BCE. Long story short, well, too late for that. The Sahara has gone through wet and dry cycles due to changes in the climate and weather patterns over thousands of years. Up until recently, we've known about the Sahara in its dry era, but in September 2024, an unusual cyclone rolled through. It hit Morocco, Algeria, Tunisia, and Libya, and filled those dry lakes and rivers. The satellite images from NASA of before and after the rains are stunning. It's like the Sahara has had a makeover. Some areas in North Africa received up to 8 inches of rain. For comparison, Seattle gets about 40 inches per year, only 5 times what the Sahara received. I say only for one simple reason. Seattle has a reputation for being quite rainy, while the Sahara does not. The tricky part is those 8 inches. Essentially, the entire yearly quota for this area fell in a matter of moments. So, in a way, it might have felt rainier in the Sahara than in Seattle. The mountains funnel the water into ephemeral lakes in northern Algeria, which recently expanded to over 70 square miles and reached depths of more than 7 feet. That's enough water to sustain it for a year. So what exactly are these ephemeral lakes? Well, they're basins that fill up for a short time each year, but might stay dry for several years if the rain doesn't cooperate. Sometimes water flows into them from a small surrounding area, or it can just be good old-fashioned rain. Now, a big question arises: how come these lakes exist in the first place? Well, generally they form because there's excess water trapped on the surface. But the soil in the Sahara is incredibly dry. Shouldn't it act like a sponge? It must be thirsting for moisture. Well, think about how eagerly your potted plant drinks up water when you return home from a vacation. However, no matter how parched it is, dry soil can only absorb a limited amount of water, which is often quite small. And just like your potted plant, it doesn't necessarily drink it all. You might simply be overwatering. Or, if you check the saucer below, you could find a mini flood. Another significant factor preventing the soil from absorbing water is the lack of vegetation. Under normal conditions, trees, shrubs, and various plants help retain moisture. In the desert, however, it's nearly impossible. There may be a few palm trees, but that's about it. This also explains the formation of those temporary lakes. Precipitation that isn't held by plants accumulates in low-lying valleys and depressions, creating these fleeting bodies of water. These lakes may only last for a limited time, but that doesn't mean they shouldn't have names. For instance, the beautiful lake adorned with swaying palms that you see is called Lake Yasmina, located in the oasis town of Merzoga. In certain areas of the desert, where the dunes rise, it may appear as though you're looking at a mirage, but it's not. The sand dunes are partially covered by water. Remember how I mentioned 8 inches? Well, that's not entirely accurate for some regions. In fact, there are places where the flooding is so extensive that the palms are submerged up to their crowns. Now, the last time we saw a downpour this intensive was 30 to 50 years ago. But this rain is more than welcome. After 6 consecutive years of drought, Morocco really needed it. Lakes that had been dry for decades, like Lake Ariki, are finally getting some much-needed water. A recent analysis revealed that out of the hundreds of storms that have hit the region since 2000, only 6 brought enough rain to start filling up this lake. And of those, only 2 resulted in a lake level higher than what we saw in September 2024. So while this torrential rain seems like a blessing, the big question is, will it last? The answer is yes. When humid air from near the equator meets the hot, dry air from the north, the Sahara Desert tends to get more rain. Scientists say this collision zone is shifting further north as the planet warms, and it warms, so it's likely to keep moving that way over the next couple of decades. So I seem a bit overly optimistic about this, and the truth is, the news isn't entirely positive. The reality is that no one was truly prepared for a flood situation like this. Moreover, remember that this isn't some Southeast Asian country where people are accustomed to dealing with water. This is the bone-dry Sahara. That said, I think you know what I'm getting at. Tragically, at least 18 people lost their lives to the intense rains in southern Morocco. The authorities are gearing up for even more heavy rain in the region. But if that's the case, could it mean the Sahara is facing extinction? And what would that even mean for us? It might sound a bit strange, but our planet actually relies on deserts, and the Sahara is no different. At first glance, it may seem like a barren wasteland, and it's nothing to write home about. But deserts play a crucial role in our ecosystem. They act as major carbon storage sites and are considered net carbon sinks, with the Sahara alone holding an estimated 1 trillion metric tons of carbon. In the fight against climate change, these existing deserts are like a buffer, helping to keep the temperatures within acceptable levels. Yeah, deserts are scorching hot, but they act as the world's air conditioning. Plus, desert sands are an unexpected source of nutrients for lush areas like tropical rainforests. Believe it or not, scientists have found that the sand particles from the Sahara have a hand in nurturing the Amazon rainforest. These particles travel across the Atlantic Ocean, riding the winds all the way to South America, where they enrich the soil in the Amazon basin. Without the Sahara, experts believe the Amazon rainforest could face serious collapse. Well, there you are. The sun is scorching, you're thirsty. All you can think about is water and ancient bones under your feet. You're wandering through the Sahara, the largest hot desert on Earth. Right now, you're crossing a stretch of sand called Whale Valley. And all over these 75 square miles of land, fossils cover the ground so thickly that you can't help but step on them. Paleontologist Hesham Salam says it's an unusual picture in this place. The bones are poking right out of the cliffs, as if they're calling to you to come check them out. You can spot ribs scattered all over the place. Look at these vertebrae. They're giant. Ooh, the creature they once belonged to must have been up to 65 feet long. The fossils show that the animal had a streamlined body like today's whale, but still had features like hind legs and feet. For scientists, it means a very exciting thing. They might have discovered a fully intact skeleton of a prehistoric whale. It was an animal that lived in this area when Egypt was underwater. You see, today, the Valley of the Whales is the world's largest ancient whale graveyard. You're likely wondering what marine animals are doing in a desert more than 100 miles away from the nearest coast. Well, millions of years ago, This desert was at the bottom of a massive ocean called the Tethys, which stretched from Europe to India. When sea levels dropped, the ocean left behind a seabed covered with fossils. And today, the fossils of some of the earliest known whales rest here, which gives researchers a peek into how today's massive ocean whales may have evolved. The fossils here are super detailed, even with some stomach contents still intact. Uh-oh. Scientists have also found fossils of ancient sharks, crocodiles, and turtles, helping to recreate what this marine world looked like millions of years ago. Now, the first whale bones were discovered in 1902, but it wasn't until the 1980s that people really started to explore the area, only when access to this area became better. Sadly, some fossils had been taken away by collectors before the site turned into a protected area. Most of the fossils are just under the surface, slowly revealed by erosion. Whale Valley gives us an amazing glimpse into millions of years of ancient coastal marine life. But let's move further. Ancient whale fossils aren't the only discovery you're going to make today. For over 150 years, scientists have been puzzled by a strange creature that lived millions of years ago. But now, thanks to some amazing fossils found in Morocco, they've finally figured it out. Look at them. These creatures are called blah blah blah. Nah, I'm kidding. Styophorans. They look like flattened armor with a long arm sticking out. Researchers discovered these creatures in 2014 and were shocked. The fossils dated back around 478 million years. They found around 450 specimens, and to their surprise, some even had soft tissues preserved, which is super rare. Before this, they only knew Styophorans from their hard parts. Originally, scientists thought these creatures were good old echinoderms, animals like sea urchins and starfish. But new discoveries prove that they had a core body and feeding arm similar to modern starfish, complete with a water vascular system to help them move and eat. This finding ends a long debate about where Styophorans fit in the animal family tree. Now we know they're related to echinoderms, but are more advanced because they don't have the typical 5-ray symmetry. Ooh, come here and look at this giant fossil. It was found in the Sahara and gave scientists new insights into the Spinosaurus, the largest carnivorous dinosaur we know about. These 95 million-year-old remains also confirm that it was the first known swimming dinosaur. The Spinosaurus had flat paddle-like feet and nostrils on the top of its crocodile-like head, perfect for staying underwater. It was a pretty weird dinosaur with a long neck, trunk, tail, and a 7-foot sail on its back, so it must have spent a lot of time in the water. At over 50 feet long, Spinosaurus might have been even larger than T-Rex. The first Spinosaurus remains were discovered about 100 years ago in Egypt, but only this new fossil, found in Morocco, helped scientists reconstruct this dinosaur for the first time. Researchers paid attention to the creature's shorter hind limbs and wide claws. These features point to adaptations for life in the water. Its snout and dense bones also suggest it was a swimmer, while its spiked tail likely attracted mates. Hey, good looking, come here often? And here's another astonishing find made in Tunisia, the remains of Machimosaurus rex. Now, so far it's believed to be the biggest crocodile ever. This ancient croc was about 32 feet long and weighed around 66,000 pounds. It was a top predator around 130 million years ago, and its skull was over 5 feet long. Now, this discovery is a big deal because it shows that these crocs stuck around longer than we thought. Before this, scientists believed that they disappeared during a minor extinction event between the Jurassic and Cretaceous periods. Now, let's go back to the fact that the Sahara was once underwater, and some of the largest sea creatures ever lived there. A study published in the Bulletin of the American Museum of Natural History speaks about an ancient body of water called the Trans-Saharan Seaway. It existed between 150 million years ago, covering parts of Western Africa. Scientists spent 2 decades trying to recreate this prehistoric underwater world. They found it was warm and shallow, home to some pretty terrifying creatures, including 5-foot-long catfish and 40-foot-long sea snakes. Yikes! The seaway was cut off from larger oceans for long stretches, which may have helped these predators grow larger because resources were always available. It's a classic case of evolution at work, leading to what scientists call gigantism in isolated environments. But all that water didn't just disappear with no trace. Under the sands of the Sahara, scientists have discovered a massive ancient lake, which they're calling a megalake. Makes sense? This lake formed around 250,000 years ago when the Nile River flooded the eastern Sahara. At its biggest, this lake covered over 42,000 square miles. It's about half as big as Kansas. They also found evidence of a smaller lake, 93 miles west of the Nile, at a slightly lower level and covering 18,600 square miles. All of this adds to growing evidence that once, North Africa had many lakes that might have created migration routes, helping early humans move across the continent. Now, in the Sahara, you can find not only fossils of bizarre animals. In May 2020, some weird rocks with greenish crystals were discovered in a sandy region in southern Algeria's Sahara Desert. When scientists checked them out, they found out these rocks weren't from Earth. They were actually pieces of a meteorite called Erg-Czech 002. This meteorite is super old, like the oldest volcanic rock ever found. It melted ages ago in the fiery heart of an ancient protoplanet that no longer exists. Researchers had recently published a study in Nature Communications, revealing that they have analyzed lead and uranium isotopes in Erg-Czech 002 and found out it's more than 4.5 billion years old. Another cool discovery made in the Sahara is quite unexpected. A few years ago, scientists found what they think are the world's oldest colors, and they're bright pink. These pigments were uncovered from rocks that are around 1.1 billion years old in the Sahara Desert. The colors came from microscopic organisms, as animals didn't exist back then. The discovery was made by a PhD student who crushed the ancient rocks and analyzed the pigments. These pink pigments are actually ancient chlorophyll from photosynthetic organisms that lived in an ocean that's long gone. Researchers are now sure that this finding could help explain why larger, complex creatures showed up much later in Earth's history. Before these colors were discovered, scientists didn't know what was missing in the food chain that delayed the evolution of larger animals. Now they understand that tiny cyanobacteria were at the bottom of that chain. Apparently, this discovery is not just about finding some old pink stuff. Scientists believe it's a breakthrough in understanding the history of life on Earth.
Name a desert. Let me guess. Sahara? Well, actually, no matter which one you thought of, I'm sure of one thing. It's located somewhere below this line. See, when we hear the word deserts, we usually picture dry, sandy, blazing hot places, and there's not a single one of those above 45 degrees north latitude, or below 45 degrees south. In the south, that kind of makes sense. I mean, if you leave out Antarctica, there's not a whole lot of land down there. But things are different above 45 degrees north. There are tons of land. Countries like Canada, France, the United Kingdom, and a bunch of others. And still, not a single desert. Actually, not a hot desert. Most of the major hot deserts are up in the northern hemisphere, near the tropics of Cancer and Capricorn. And the hottest ones are usually found between 15 and 30 degrees north or south of the equator. Just like the Sahara, where average high temperatures can reach up to 104 degrees Fahrenheit. Together, hot deserts cover almost 15% of the Earth's land area. But if our planet is packed with them, why doesn't a single one appear above this line? I mean, the 45 degrees north latitude. I'll explain. Let's divide Earth into 5 main zones. The polar regions are located at both ends, north and south. Right here, we have the 2 temperate zones. And finally, right in the middle of the globe is the tropical zone. Now, the line we're talking about sits in the temperate zone, in a colder area. Because the farther you go away from the equator, the colder it gets. Actually, the average annual temperature drops about 1.2 degrees Fahrenheit for every degree of latitude you move north in the northern hemisphere. and cold weather is the main reason hot deserts don't form above this line. It turns out that as you move farther north from the equator, the sun's rays hit the Earth at a more slanted angle. That spreads the solar energy over a larger area, which means less heat is concentrated in one spot. Basically, these regions just don't get as hot. And it's one of the reasons why countries like Finland are much colder than Colombia, for example. Another reason temperatures are lower in this zone has to do with something called albedo. Basically, this term refers to the amount of sunlight that a surface reflects back. Let me give you an example. Every surface on Earth both reflects and absorbs sunlight, but in different amounts. Take snow, for example. It can reflect up to 90% of the sunlight that hits it and only absorbs about 10%. That's what gives snow a high albedo. And it's totally different with sand, which has a lower albedo. In places like the Kalahari Desert, down in southern Africa, it's about a 50-50 situation. Most of the year, roughly 50% of the sunlight gets reflected around there, and the other 50% is absorbed. The heat absorbed by the sand is part of why it gets so hot in dry places like deserts. Hot deserts. Simply put, sand soaks up more heat, while snow reflects most of it. This is one of the reasons why snowy areas stay much cooler. So the closer you get to the polar zones, the easier it is for sunlight to be reflected instead of absorbed. And that helps explain why there aren't any hot deserts around those parts. Then, we also have atmospheric patterns. Let's just say that the air patterns change a lot once you go above that 45-degree line. That's because this region is controlled by a wind belt known as the Ferrel Cell. Okay, so Earth has three main convection cells. You can think of them as big loops of moving air. Warm air rises, cools down, sinks, and then the cycle repeats. At the top and bottom of the planet, we have the polar cells. Right in the middle are the Hadley cells, and sandwiched between those two are the Ferrel cells. Now, everything that happens between these three cells can get a little complicated, but for today, the main thing to know is this. In those middle zones, the warm air that comes from the tropics meets the cold air from the polar regions. So, Ferrel cells play a big role in moving heat from the equator up toward the poles. This flow of warm air helps smooth out the temperature differences between the tropics and the polar regions. And that's what shapes the weather in places like North America, Europe, and parts of Asia. In the mid-latitudes, the Ferrel cell keeps the air moving around so much that hot, dry air doesn't really get a chance to settle. So, those regions end up with more moisture, more clouds, and even storms, rather than dry, desert-like weather. That's why you don't usually see hot deserts around 45 degrees latitude. Basically, what I'm trying to say is that the Ferrel cell makes the weather less stable. And that's very different from what happens in the Sahara Desert, for example. Over there, temperatures don't change all that much throughout the year. Just expect it to be hot. When you put all these factors together, it helps explain why hot deserts are mostly limited to the middle parts of the Earth, and why you'll never find a Sahara or Kalahari-style desert in places like Canada or Sweden. But that doesn't mean we don't have any deserts above the 45-degree line. Turns out, deserts don't always have to be hot and sandy. In fact, they can look like this. Yep, I'm talking about the Arctic. Because the actual definition of a desert isn't just some hot, dry, sandy place, it's really any area that gets very little precipitation. In other words, an area where it doesn't rain much. And it usually gets no more than 10 inches of precipitation per year. So no matter if the weather is hot or cold, deserts are really dry places with hardly any vegetation around. That makes it pretty tough for animals and plants to live in those environments. If you think about it, that means the biggest desert on Earth is Antarctica. It covers about 5.5 million square miles, just endless ice flats as far as the eye can see. It's also the coldest desert on the planet, even colder than the Arctic, which is the other polar desert. Temperatures there can drop as low as minus 128.2 degrees Fahrenheit. If you look at the Earth, about 33% of its land is desert. Now, pay close attention to the ones located between 15 and 30 degrees latitude. These are called tropical deserts. But can you notice something curious about their locations? Most of them are found on the western edges of continents. And there's a reason for that. Actually, 4 main reasons. First, the winds that bring rain usually blow from the east. When they move across the land, they drop most of the rain early on. By the time these winds reach the west side, they're dry, so there's no rain left for those areas. That already makes things pretty dry. Second, in the western margins of continents, the air usually goes down instead of up. When air goes down, it gets warmer and can't form clouds, so again, no rain. Third, if there are mountains nearby, they can block the rain too. One side of the mountain gets all the moisture, and the other side, called the rain shadow, stays dry. And lastly, the ocean near these places often has cold water. Cold water cools the air above it and makes it calm, so clouds don't form easily. No clouds means no rain. So when you put all of that together, it helps explain why those tropical deserts seem to prefer one side of the continent more than the other.
You find yourself in Africa, land of unique wildlife, home to a great variety of cultures and languages, and, first and foremost, host to the world's largest hot desert, the Sahara. It's daytime, and you are thirsty for some water and shade. You've been walking for days, trying to find one of those precious-looking oases. You feel you're near, but the horizon just keeps stretching and stretching. Your mind is tired, and your body is feeling all the heat. It's like you've eaten a full plate of hot pepper and then some more, judging by how much you're sweating. And when I say hot, think 100 degrees Fahrenheit hot, on average. No wonder this is happening. After all, you find yourself in the world's biggest hot desert. Now, I say hot desert since the biggest deserted landscapes are actually the cold ones, located in Antarctica and the Arctic. Icy Antarctica's frozen desert is more or less the size of 1 million LAXs. Yep, the Los Angeles International Airport. The Arctic desert is just a bit smaller than that. Now, in case you don't know, the Sahara Desert is located in northern Africa, stretching from the Atlantic Ocean all the way over to the Red Sea. It occupies an area large enough to place approximately 100,000 Disney World theme parks side by side. According to scientists, its boundaries are expanding. Deserts usually form in the subtropics because of what's called Hadley circulation. The air rises at the equator and descends into the subtropics. This circulation of air has a drying effect, which helps the formation of desert landscapes. Since the 1920s, the Sahara is considered to have expanded by over 10%. How is this happening? Well, let's start from the beginning. You probably know the Sahara Desert as one of the most inhospitable places on Earth today. Just FYI, for a place to be considered a desert, it has to receive less than 4 inches of rain per year. Due to the very small precipitation index, deserts are usually dry and arid places. There is little humidity in the air, and daytime temperatures can go as high as 130 degrees Fahrenheit. Usually, there isn't that much animal and plant life because of the lack of water. But in the Sahara's case, it wasn't always like that. It may be difficult to imagine northern Africa without the tons of sand it has today. But about 20,000 years ago, the Sahara was actually one big oasis. Recent discoveries show clear evidence of what the scientists now call the Green Sahara. In the mid-1800s, a German explorer crossing the Sahara encountered some paintings and engravings that nomad artists had left behind. What he saw in those paintings looked nothing like his actual surroundings. Instead of an arid landscape with only camels and desert vegetation, the rock paintings depicted jungle animals like giraffes and hippos. There were even images of livestock and grazing animals, such as cattle and sheep, something that seems impossible for modern-day Sahara. Artists usually draw what they see around them, so this finding really intrigued the German explorer. The drawings were so detailed that the artists must have had close contact with those animals. You can find this rock art spread out in the northern part of the African continent, from western Sahara to Saudi Arabia. Geologists soon took a keen interest in this and found the first clues to what this could mean. They have been able to confirm that, in fact, northern Africa was once much wetter. They found evidence from nearby deep-sea sediment off the coast of Mauritania. Sampled cores of underwater sand and mud, known as Saharan dust flux, show geologists that, indeed, a green Sahara was possible. The more dust is blowing off of the desert and into the bottom of the ocean, the drier the climate in the region. The sediment cores show that there was much less dust, only half as much, coming off northern Africa during the humid period. This period has to do with Earth's natural cycles. Normally, the Earth rotates at a tilt of 23.5 degrees, but this angle is not consistent and changes over time. Earth's tilt is responsible for the amount of sunlight each hemisphere receives. It affects several ecosystem functions on the planet. During the time of the Green Sahara, the Earth received between 4 and 8% more sunlight than it does today. So when the Earth tilted about 20,000 years ago, the northern hemisphere received more direct sunlight, which affected humidity levels in the region. As the northern hemisphere got warmer, this affected monsoon activity, more specifically the West African monsoon. Monsoons are wind systems that affect a region's rainfall index and humidity levels. As a part of the globe gets warmer, it allows for more air to rise. It combines with the wind to draw moisture up into the atmosphere. Little by little, northern Africa also became wetter. The increased moisture made the Sahara so wet that there were actual bodies of water in the region. As vegetation grew, the plants held onto moisture better than bare sand could. There is evidence of natural basins throughout the Sahara and lakes so big they would fit all of the U.S.'s Great Lakes inside of them. Archaeologists uncovered evidence of vibrant societies in what are now arid areas. It looks like ancient cultures were able to take full advantage of the African humid period. According to researchers, the human population peaked across the Sahara about 9,000 years ago. There are traces of fireplaces, hunting tools, fishhooks, and even mounds of fish bones. Records show that there have been over 230 green periods over the span of 8 million years. Solar radiation is always changing due to natural orbital cycles. That's why Earth will most certainly see another green Sahara moment. It might be thousands of years from now, but it will happen. The same way the Sahara turns green, it turns yellow again. Let's put it like that. All it takes is a significant axial tilt and a few years of readjusting. However, another phenomenon is calling the attention of scientists now. Recent studies by the National Science Foundation from the University of Maryland show the Sahara has expanded 10% over the past 90 years. This phenomenon is called desertification, which literally means fertile land turning into desert land. The Sahara Desert is now advancing into the semi-arid region of Sahel. In 1950, this region was home to 31 million people. Today, its population is over 100 million people. This rapid population growth has largely contributed to the Sahara's expansion. Farmers that were once nomads began settling down. Land usage grew more intense, aiding in weakening the soil. The demand for food has caused an overcropping of the land, so even more of it is turning into the desert now. The study also shows that natural climate cycles can affect rainfall in the Sahara and the Sahel. Scientists affirm that all deserts fluctuate, not only the Sahara. A desert's boundary may expand in the dry winter and contract during the wetter summer. South of the Sahara lies the Chad Basin. It is a natural body of water that now serves as an indicator of the Sahara's expansion. The Chad Basin is located in the region where the Sahara is advancing southward. An atmospheric and ocean expert from the University of Maryland explains that rainfall has reduced greatly in the entire region. Due to reduced rainfalls, there is less water across the entire basin, and even Chad Lake is drying out. Just like the Sahara, the Atacama Desert in Chile, deemed the world's driest, is also expanding. It is located north of the city of Santiago, and its southern border is expanding toward the Chilean capital. Because the climate is getting drier and drier here, the city of Santiago risks turning into an arid or semi-arid region itself. The once fertile valleys of local rivers that lived on agriculture and livestock for many generations are losing their revenues as Chilean land is turning into a desert. Since 2010, Santiago has received only a third of its annual rainfall. Outside of the city, farmers are digging holes in search of blue gold, or simply put, water. The situation here is very similar to that of Sahel. So tell me this, were you as surprised as I was to find out what has been happening in the Sahara region? Feel free to share in the comments below. We've all heard of the Sahara. Sure you have. It's the largest hot desert on the planet. A sea of sand covering an area larger than the contiguous United States. But have you ever wondered what lies beneath the sand dunes? To answer this question, we must travel deep into the past of our blue planet. Up until some 6,000 years ago, the Sahara was grassland. Humans were around at this time, not me, spreading agriculture around the planet. In the north of Africa, the color green dominated. Plenty of rainfall meant that there were lakes, rivers, pastures, and even forests. A completely different image of the Sahara from the barren landscape of today. But then the climate started to shift. The region became parched, and the vegetation started disappearing. The wind did the rest. It took away the fine sediment after there were no plant roots to hold the ground together. Give it a couple thousands of years, and you get a familiar image of the Sahara. Sand and rocks stretching as far as the eye can see. But when it comes to volume, only a quarter of the Sahara is actually sand. The yellow sands of the Sahara are just one part of the story. The desert has many other features, such as gravel plains, salt flats, and plateaus. Makes you think if we understand the word desert correctly. For people who study such terrains, geologists, there is only one condition for defining a desert: precipitation. If an area gets little or no rain, then it's considered a desert. The Sahara certainly fits the bill. Its average annual rainfall is just 3 inches. Compare that to the nearly 45 inches a year in New York. When we look at precipitation, this sandy desert is only the third largest in the world. Number 1 and 2 are Antarctica and the Arctic. They are larger than the Sahara by millions of square miles. It sounds odd, but there is more than one type of desert. The first two are polar deserts, while the Sahara is a subtropical desert. But the difference in air temperature are staggering. In Antarctica's interior, temperatures plummet to minus 76 degrees Fahrenheit. Compare that to the highest temperature on record in the Sahara of 136 degrees Fahrenheit. But this desert has a cool side. At night, the temperature is roughly the same as the average yearly temperature in Denmark. This hot and cold roller coaster makes it hard to choose the right outfit when venturing into the Sahara. And what about the sand? How deep is it actually? The depth varies between 70 and 140 feet. That's not too deep. If you put the Statue of Liberty in a tall dune, half of it would still stick out of the sand. Its vast amounts in the Sahara were created by aeolian processes. That's Greek for wind. Over time, it blows and shapes the surface of the earth. In dry areas with sparse vegetation, winds erode the ground much faster. That's what happened in North Africa. Under all that sand is the bedrock and cracked clay. If you started digging, you would find the same everywhere on the planet, with one important difference. There is some type of soil covering the bedrock. This is not the case in the Sahara. Because of the arid climate and a lack of vegetation, sand covers the ground below. Over the course of thousands of years, a lot of interesting finds ended up in the desert sand. For example, there are petrified tree trunks. These are essentially preserved prehistoric trees. They date back to the time when the region was lush green. In some places, the trees of this fossilized forest are at least 65 feet tall. The wood is so well preserved that you can still see the texture and knots. There are even fossilized pine cones. In 1992, scientists found glass fragments in eastern Sahara. These canary yellow glass shards were scattered across hundreds of miles. They didn't belong to an ancient civilization, although ancient Egyptians used them to make jewelry. In fact, the breastplate of King Tut had a beautiful scarab beetle centerpiece made from this desert glass. For a long time, scientists were puzzled about the true origins of these fragments. They finally concluded that the glass was around 29 million years old. It is an impact tape. If that sounds like it has something to do with the word impact, you are correct. These rocks are formed when a meteorite hits the surface of the Earth. This generates a lot of heat. Scientists estimate that the temperature needed to melt this mineral was close to 3,000 degrees Fahrenheit. Apart from the regular fine-grained sand, we also have melted sand in the Sahara. But the desert conceals other unlikely artifacts. Shark teeth are a common find in Morocco, which sits in the western part of the Sahara. What are the fossilized teeth of these marine predators doing in the middle of the desert? This part of the world looked entirely different millions of years ago. There was a sea cutting right through what is now a desert. The Trans-Saharan Seaway ran the length of present-day Algeria and Mali. It was around 165 feet deep. That was enough for all sorts of aquatic animals to inhabit it. Large catfish, sea snakes, and of course sharks lived in the area. British archaeologists even unearthed a turtle shell in Mali in the 1980s. For centuries, there was even an entire city hidden under the desert. Timgad was a Roman outpost constructed by the Emperor Trajan around the year 100 in the current era. For various reasons, its residents abandoned it around the year 700. The sands of the Sahara soon engulfed the city. It had remained hidden for nearly 1,000 years. Then, in the 1700s, a Scottish explorer started digging out the city. His team first uncovered a sandstone triumphal arch 40 feet high, similar to the ones we can see in Rome and Paris today. An amphitheater soon popped out of the sand, and it was followed by well-preserved statues of Roman emperors. The Scotsman's find was so impressive that no one believed him at first. It took 2 more centuries for archaeologists to fully excavate the city during the 1950s. The site covers a surface as large as 10 polo fields. The ruins reveal the full mastery of Roman city planning. All the streets meet at a right angle in what is known as an orthogonal grid. You can find the same layout in modern cities such as New York. Historians estimate that during its heyday, 10,000 people called Timgad home. Different nationalities lived here, from Romans to people of African descent. Today, more than 2.5 million people live in and around the Sahara. They are spread across 11 countries in total, and their living space is growing. The desert is 10% larger than it was just a century ago. This process doesn't involve sand pouring out of the Sahara. The ecosystems on the edges of the desert simply change over time. The wind blows the soil away and vegetation dwindles. The perfect conditions for the formation of a desert landscape. These changes are happening in the Sahel, a region south of the Sahara Desert. That's why the African countries have recently come together for a project called the Great Green Wall. The primary goal is to stop the desertification of the Sahel and hold back the sands of the Sahara. Their plan is ambitious and involves planting a wall of trees from the west to the east of the African continent. The proposed forest is not only going to be long, but wide as well. The Sahara and the Sahel share a historic bond. Since antiquity, camel caravans have been making the journey from Africa's Mediterranean coast in the north to the savannas in the south. The golden age of this trade kicked off in the 9th century. The perilous journey took several months to complete. The route was 2.5 times longer than the length of the Grand Canyon. Explorers still find evidence of these ancient caravans hidden away under the sands of the Sahara. When you think of an epic desert scene with blazing sun, endless dunes, and those magical little oases, you probably picture the legendary Sahara, right? But what if I tell you that 11,000 years ago, this vast expanse of hot sand looked totally different than it does today? Yeah, I don't know, I wasn't around then. But I'm told that back then, what we now call a desert was a lush paradise, brimming with lakes, rivers, grassy plains, and even woodsy forests. So, where did all this water go? There are many stories about the distant past of our planet when deserts were covered with jungles and forests, and then something happened, like changing climates or colossal earthquakes, and it all turned green lands into dunes. But how about a theory that Sahara became a desert because of humans and goats? The Sahara has seen its fair share of wet and dry drama throughout the ages, mostly thanks to little shifts in Earth's orbital tilt, causing variations in how much solar radiation hits the atmosphere. There were even times called the African humid periods, when the rain would pour in and transform the dry landscape into a bright green haven. But between 8,000 and 4,500 years ago, something really funky happened to this region. Certain areas went from humid to dry way too fast to explain it by just orbital changes. In the blink of an eye, the lush Sahara turned into the Sahara we know today. Now, if you ask scientists why it happened, they will tell you, oh, it's just poor parameterization of the data. Bet you didn't get it, did you?
What?
Well, right, let me translate it from scientific to common human. It means they really don't know the answer themselves, and they got a bunch of missing puzzle pieces. But as scientists sifted through ancient dirt and pollen samples, they spotted a quirky trend. Wherever there were pastoralists, also known as humans with their domesticated animals, the plant life seemed to shift. It was as if every time humans and their furry friends meandered through the greenery, they turned it into scrub and desert right behind them. Oops. Yep, chances are that by overgrazing, humans were sapping moisture out of the atmosphere, since plants give off moisture, which helps make clouds and making things even sunnier, leading to a quicker end of the humid vibes. Plus, our ancestors may have been getting a little too cozy with fire for land management, further speeding up the desert takeover. Anyway, scientists are sure that this lush Sahara would have turned back into desert eventually, even if humans hadn't shown up, thanks to Earth's natural rhythms. So there's no need to pin this abrupt change solely on humans. It could simply be about nature getting feedback from vegetation and dust cycles. It's difficult to determine what caused these changes, as it's all interconnected. During the last humid period, the Sahara was filled with hunter-gatherers. As things got a little drier, they started herding animals for food. The weather pushed people to herd cattle. It's also possible that grazing sped up the landscape degradation. So, which came first, the chicken or the egg? Or in this case, the human or the cow? It's tough to tell with the evidence we have now. Now today, it's safe to say that water is no longer that big of a problem in the Sahara, even though it's a huge desert and the times of lush forests there are long gone. But technology's got us covered. For example, the Nubian Sandstone Aquifer System, the biggest underground water stash on the planet. It's nestled beneath the Sahara Desert's eastern edge and stretches across 4 northeastern African countries – Sudan, Chad, Libya, and Egypt, covering a whopping 770,000 square miles and holding around 36,000 square miles of groundwater. Just look at the pipes transported when it was being built. It's the world's largest irrigation project. No wonder it's feasible to thrive in the Sahara today. But imagine thriving in the Sahara Desert with just one water source. Sounds like a tough gig, right? But the ancient Garamantes did just that, surviving and even thriving for nearly 1,000 years without monsoons or rivers flowing to their desert paradise. These clever folks were the trendsetters of urban life in the sands, and even the Romans couldn't help but notice their genius. While many thought they were just desert-dwelling savages, the Garamantes were busy building an empire in one of the toughest climates on Earth. But how did they do that? Well, they got crafty and dug a whole bunch of underground tunnels to tap into a massive sandstone aquifer. They were literally squeezing every drop of life from under the dunes. But recently, research showed that the Garamantes weren't just hardworking, they were pretty lucky too. The Garamantes had an underground aquifer that brought water up to a hill where they built over 500 fogaras, which are irrigation systems, some stretching as long as 2.5 miles. It was like sipping water through a straw, which let them irrigate their crops for nearly a century, especially since even a little rain would help recharge the system. But eventually, due to rain insufficiency, the aquifer ran low, and reaching it again would have meant digging more tunnels and relying on more people. That's a tough problem, considering these people were in the middle of food and water shortages. Guess I don't need to tell you what happened to the Garamantes, do I? The fall of the Garamentian culture might be linked to several factors. It may have been due to climate changes, or they may have simply used their water resources too much. Back in the day, the Sahara Desert was actually fertile agricultural land, thanks in part to the cool irrigation system the Garamentians created. But since fossil water isn't something you can replenish over time, the groundwater levels dropped pretty low. This likely played a big role in the kingdom's decline by the late 7th century CE. That sounds like someone who hit a lottery jackpot, used up all the money, and went back to their original not-so-cool job once the bank account got fully drained. Oh, by the way, even if the Garamantes left some secret wisdom messages for us, the chances are we'll never get what they wanted to tell us. Nobody really knows what language they used, and their texts are nearly indecipherable to us today. But let's go back to the Green Sahara. So it transformed into a desert about 4,500 years ago. But today, we can understand how people lived in those times in the Sahara thanks to natural parks in Africa that have the ultimate outdoor art gallery. There are well over 15,000 ancient paintings and carvings depicting everyday life from around 11,000 years ago. However, if the carvings aren't enough for you and you feel like visiting an actual green desert, all you have to do is book a flight to California. One of the most beautiful phenomenon in the world, the superbloom, takes place here. Look at all these colors – orange, green, pink. It's a miracle. Wildflowers bloom right in the middle of a hot desert after several years of rainfall in dry places. It's such a bright and colorful landscape that superblooms can be seen from space. This rare phenomenon can be observed in other arid places and deserts in western and southern Africa, western Australia, and Chile. In all these places, the weather is very hot and dry in summer. Mild humid air comes in winter, and this is the ideal environment for mass flowering. Flower seeds that lie in desert sands can wait for decades before starting to produce flowers. When the hot sun destroys all the weeds and grass, and the rainfall becomes enough to moisten the soil, the seeds are kind of like, well, okay, now it's our turn to play a big game. And then hundreds of thousands of tourists come to take photos and post these beautiful pictures on social media. And this, unfortunately, is one of the main dangers for flowers. Therefore, if you find yourself in a place like this, don't pick the flowers and don't trample on them. Stay on the path, don't litter. Take only pictures and leave only footprints. You get it? Good. So the Sahara Desert is so big that it covers 8% of the world's territory. It's bigger than the USA or China. Surprisingly, the Sahara is not the largest desert in the world. It is the third largest, behind Antarctica and the Arctic. But it is definitely the hottest one. Temperatures there reach 136 degrees Fahrenheit. This place has some of the most incredible sand dunes you've ever seen, towering up to 1,476 feet. But here's the kicker. There's a real risk that these dunes might continue to spread until they cover the entire world. Surprisingly, the influence of the Sahara Desert extends far beyond its borders. Its dust, carried by powerful winds, makes its way to the UK and across the European continent, particularly in winter. This dust settling on the ground where it rains is a familiar sight to those in the UK, often leaving a red residue on cars. This connection between the Sahara, England, and Europe serves as a stark reminder of the global reach of environmental phenomena. You might think this is not a big deal, but it could turn Europe into a desert, leaving its soil infertile and Europeans with no food. Soil is a fundamental aspect of human existence, just as crucial as clean water and air. Without it, we're left with nothing but a bleak and barren landscape. The Sahara Desert has already made its jump across the Mediterranean Sea, which is concerning and could change the landscape forever. 1/5 of Spain has already turned into a desert. The next victim is Italy, which also faces the problem of desertification. In fact, almost all European countries have the same issue. According to an expert, the land that has not changed for nearly 2,000 years will become mostly rock, and people living on this land will be gone. 60% of the soil in Moldova is gone, and the problem has expanded beyond the Black Sea. It has reached China and Mongolia, thousands of miles away from the Sahara Desert. All of this causes losses of $4 billion a year. The threat is so significant that even the UN has gathered the necessary resources to solve the problem as soon as possible. Italy is sending help to Africa to stop the Sahara Desert from expanding. If this process does not stop in the next 10 years, millions will be forced to leave their homes. The Sahara Desert is growing for approximately 30 miles per decade. You do the math and see how long it will take to cover Europe. Since 1920, the Sahara has expanded by around 10%. But not all hope is lost because more than 172 countries have joined to put a stop to the desertification of the world. The World Food Program is a project that aims to help bring back green land that was once present in the Sahara. When they told people who called the Sahara home what they were about to do, the latter basically laughed in their faces and said it was impossible. But when you have a specific goal in mind, the impossible becomes possible. If we traveled back around 5,000 years into the past, we would see a beautiful forest with lush green trees and grass. Africa's climate has been changing for 21,000 years, from fantastic greenery to uninhabitable deserts. This has to do with Earth's rotation and the monsoons that bring water to this dry continent. But with the help of scientists and some clever tricks, we can bring the greenery back and stop the Sahara in its tracks. The Senegal River serves as a border between the Sahara Desert, Senegal City, and Mauritania. When you look at this area from space, you'll see how the desert is expanding to Senegal because the vegetation along the riverbank is almost non-existent. Forests can serve as a barrier, stopping the sand from getting blown away and the desert from expanding. An effort to create a great green wall is being made, and how they do it is actually quite impressive. Nothing has been growing in the currently restored area for more than 40 years, making locals find other places to call home. People were thrilled when they saw that the land could be restored. They're very committed and learn to work with the soil and grow food. At the same moment, more than 30,000 hectares have been restored and transformed into lush greenery. The Sahel region is the starting point of desertification, and it is crucial to establish a green wall in that area first. To make this wall is not rocket science, since it only takes a few simple steps. The ground there is baked by the sun and as hard as a block of concrete. If you've ever poured water on concrete, you know that it just flows away. It doesn't stay in one place. So they had to create water-retaining half-moons that would hold the water and make it available to plants. When you learn about how these half-moons work, you might say, how did they not think of that sooner? Actually, this technique is ancient, and it was once implemented in Sahel, but it was lost over time. When the rain falls, the water is collected into the half-moons that are positioned a bit lower than the ground below contour lines. There is also a kind of bank at the end of the shape that prevents water from overflowing. And in the middle, there are plants that are happy because they have plenty of water to thrive. Also, it's essential to grow native plants that are kind of used to harsh conditions, like sorghum and millet. These plants have been surviving there for thousands of years and produce a good amount of biomass, which means the land can be rehabilitated faster and people will have food sooner. The water that will enter the half-moons won't be lost. It will penetrate the ground and top off underground waters. This will ensure the ground that H2O will never run out and that future generations will have usable aqua. This brilliant planting technique is not limited to half-moons. People also create lines and plant various vegetables, such as tomatoes. Next, there are places only for trees, like lemons or oranges. After a long hot day, nothing is better than a freshly made cold lemonade. The trees will also protect the soil, and with some luck, there will be a new forest in the Sahara Desert. The goal is to copy the forest dynamic. Start with small plants and gradually expand to bigger plants that are more useful than the tiny ones. They are aiming to plant more than 10,000 trees. Right now, many people are leaving the Sahara after the rainy season, going to cities or leaving Africa altogether. At this time of year, villages are like ghost towns. Only animals can be found there. Most people are gone. I mean, who would blame them? Nobody wants to live in the sand where nothing grows. Luckily, with all this new, old technology being developed, many people are slowly but surely returning to their land and starting to work in agriculture. The best thing is that there are no brutal winters, so plants grow 12 months a year, and people can always have food. People are becoming more social because now everybody stays in their villages and doesn't travel much. If this project works out, Africa will be saved, and the world won't turn into a giant desert.
You're flying over the Sahara Desert in a small, light aircraft when you spot something truly weird. It seems to belong to a very different part of the world, the ocean. But what ocean can be huge enough for this monstrous sea star to dwell there? You descend and realize that it's not a sea star. It's a towering dune with a pretty unique shape, and it's not alone. From afar, these magnificent sand structures look a bit like pyramids. They have pointed tops and radiating arms. Called star dunes, they're the most complex and largest desert dunes in the world. They're the tallest of their kind, but that's not the coolest thing about them. Researchers have found similar formations on Mars and even on one of Saturn's moons, Titan. Star dunes aren't super rare, but they're especially widespread in southeastern Morocco near the border with Algeria. That's where you're flying at the moment, and the breathtaking dune you're marveling at is Lella Lalia, probably the most famous of them all, a giant 330 feet tall. Scientists believe that it formed in less than 1,000 years. How about doing some research to find out more about these unusual formations? There, I see a great spot for landing. Star dunes got their name because of their multi-armed shapes. They form in areas where winds change direction throughout the year. But even though you can find them in different places on our planet, there is just one confirmed star dune in the rock record, the collective record of Earth's development reflected in preserved rocks. The star dune in question is in Scotland, and it's ancient, from about 250 million years ago. That's all we know about super old star dunes. Probably because we don't know what to look for to identify one. Another problem: star dunes often form in remote locations, which makes them extremely difficult to study. Imagine reaching the nearest settlement, then somehow traveling who knows how many miles to the dune itself, and then slogging up several hundred feet of shifting sand. I'll pass. But you can go since you've already landed, and the dune is right here in front of you. Currently, you're in a dune field called Erg Shabi. Lucky for you, this area has long become a popular tourist stop. Look, in the distance, there are hotels and even a good road. Scientists who examined Lella Lalia before you used ground-penetrating radar to find out more about the sand formation. This equipment can detect the tiniest differences in sand grain sizes and water content under the surface of the dune. That's how you can create a picture of its interior layers. Look out! Phew, it was a close call. See this trench? The researchers dug such trenches to take samples of long-buried sands and then examined them. It's a pretty cool process. The thing is, while buried deep inside, the quartz in the sand accumulates radiation coming from natural sources within our planet. We can compare the grains of quartz to minuscule rechargeable batteries. They can store the energy they get from radiation. When researchers bring them to the laboratory, they can make the grains release that energy, which comes out in the form of light. Scientists can measure the brightness and say when the sand enjoyed sunlight for the last time. Now, when those experts who dug the trenches looked inside Lella Lalia, they were shocked. The enormous formation turned out to be very young, for a dune, of course. You'd expect a dune that is several hundred feet tall to be pretty old, like thousands or tens of thousands of years. But that wasn't the case. Well, at least not entirely. The upper part of the dune has turned 900 just recently. But look at the sand near the base of the dune. Yep, right there. Well, it was buried there around 12 or 13,000 years ago, representing ancient dunes in the area. Those good old dunes were active for a couple thousand years, and then something went wrong. Because for a whopping 8,000 years, the sand wasn't accumulating there. A mystery? Scientists might have an explanation. You see, the first part of this quiet period occurred during the time when the climate became warm and wet. Yep, even in the Sahara. It happened about 11,700 years ago. It was the end of the last ice age and the beginning of a new era, the Holocene. And guess what? The Sahara went green. It started blooming like your local botanic garden. Plants started popping up all over the place, stabilizing the sand. If you had visited the Sahara during that period, you wouldn't have recognized this place. But you would have likely come across humans wandering marshy landscapes and hunting for food. Researchers have found pottery fragments and stone tools on one side of Lelalalia. That's true. As sand dunes form and then shift throughout their lives, they swallow and protect ancient remnants of life. Just dig well enough and you might find something that will provide you with a window into the past. It can be ancient fossils, anything from fossilized shells and corals to prehistoric plants. Those can offer precious insights into the history of our planet and the living beings once inhabiting certain regions. Now, it might come as a shock, but in the Sahara Desert, scientists have uncovered well-preserved marine reptiles and fossilized fish within the layers of those ancient sand dunes. They are the remains from the time when the Sahara was covered with a sea millions of years ago. Anyway, it's time to leave that ancient paradise if you want to survive. 4,000 years ago, the wet period came to an end, and the Sahara dried out again. Interestingly, our dune didn't begin building up right away. For some time, sand probably blew through but didn't accumulate. Or the dune could have started growing in a different location. And it's a valid theory since scientists have discovered recently that Lelalalia shifts around 1.6 feet every year. It also accumulates about 6,400 tons of sand every year. Now, if you've been inspired by your dune trip and are now eager to explore more of them, I've got some unpleasant news for you. Unfortunately, although there might be star dunes locked in sandstones around the globe, they're super tricky to detect. The problem is, dunes are huge, but they lack a single distinguishing feature. So you'd really need large exposed beds of rock if you want to get a wide enough view to identify a star dune. On the bright side, there surely are places where it might be possible to do such research, but you should be ready to know that it might be just a set of various features that look like other dunes. But if you combine them, you'll say, it's likely to be a star dune. Comment below if you'd like to go on a trip in search of a star dune. Meanwhile, we'll continue our journey. You decide to have some rest and start climbing down the side of the dune. That's when you begin hearing it. Terrible, haunting sounds. Are there ghosts nearby? Worry not, you're safe. You might have heard of a phenomenon called singing sands. As you walk down some sandy slopes, you disturb the grains of sand. They rub against each other, producing friction that creates those eerie melodies. With each step, the sand beneath your feet comes alive in a ghostly choir of whistles and whispers. The sounds range from low hums to loud, high-pitched wails, as if an otherworldly symphony is echoing through the dunes. But of course, scientists have their own very practical explanation, attributing this phenomenon to the right atmospheric conditions combined with the unique size, shape, and moisture content of the grains. Now you've almost made it all the way to the bottom of the dune, but beware of slip faces. When a sand dune reaches a certain steepness, it develops a slope. That's the very slip face I was talking about. This slope is usually on the leeward side of the dune and sheltered from the prevailing wind. Sand grains start accumulating on the windward side, slowly creeping along the dune's gentle slope. At one point, they reach the top. Gravity takes over and they start sliding down, triggering a cascading effect. It looks like a miniature sand avalanche, and I wouldn't want to end up in its way.
you plan to spend your summer vacation in Africa. The final destination is the Sahara Desert. It's located in northern Africa, stretching from the Atlantic Ocean to the Red Sea. You're excited to ride camels and learn about the region's rich cultures. You hop on an extensively long flight, and finally, you are here. You find yourself in the world's biggest hot desert. Can you believe it's 3 million square miles? You're ready for your first adventure after drinking liters of ice-cold water. The guide gives you a choice. You can spend 2 weeks visiting a collection of oases, or you can help them solve an ongoing local mystery. Deep into the desert, near this Algerian town, lies a mystery begging to be solved. A collection of huge, spotted circles in the sand. There are dozens of them, stretching for miles in a straight line. The circles were first identified via Google Earth images several years ago. People have debated them for years, but no one seems to know the answer. The strange thing is that they are so many miles away from any towns, roads, or human activity. The quickest way to discover the truth behind the circles is asking questions. You grab your notebook and set out to talk to locals. Everyone is helpful in this scenario: geographers, anthropologists, elders, and historians. The first person you talk to is a map expert. You need to understand if those circles were authentic or a satellite glitch. You end up interviewing the people who take Google Earth satellite pictures. The circles are really there. They appear in multiple pictures from many years. Then, let's understand why they are there in the first place. After 2 days of interviews, you have your first lead. The circles could be the result of oil activity. Experts explained why this would make sense. Algeria is a rich area for natural resources, so this would be a sensible guess. Usually, to find out if there is anything worth extracting, companies would undertake seismic surveys. Seismic surveys are a way of analyzing the Earth's surface by sending shock waves into the ground. Depending on how these waves bounce back, you'll know what is located there. A special vehicle could have marked the soil that way. So, did we unravel the mystery? Not quite so. As you know, the Sahara Desert is one of the driest areas on the planet. The average high temperatures in summer are over 104 degrees Fahrenheit. To survive there, people need to find ways of accessing water. So, these circles could be a kind of ruin or leftovers from ancient water wells. Again, I'd say this is a sensible guess. Ready for some fact-checking? Some anthropologists agree that these circles could be ancient fogueras. Foguera is the name of a 2,500-year-old style of irrigation system, usually found in northern Africa. It is also known as a qanat in other places in northern Africa. Locals would dig a deep well at an elevated point, deep enough to tap into underground water. They would then dig parallel shafts at regular distances. Then they would dig an underground channel that connected the city to the well. Solely with the help of gravity, water would run from the well to the city. This traditional technology provided water for crops, livestock, and humans. Now, let's say these wells made human-made oases possible. Even the closest municipality name was an indication that this could be true. The name Fogueret Essaouira is actually named after Foguerets, these ancient wells. Now, this lead was proving to be very accurate. You decide to travel over there to see for yourself. You take a local bus, sit back, and enjoy the ride. The landscape in northern Algeria is filled with ancient-looking towns. You even see ruins of wells along the way, on the outskirts of smaller cities. Opening Google satellite images, you can see the qanat's markings on the ground, a series of holes running down several miles. But as soon as you arrive, you find out you were wrong. Dale Lightfoot, one of the world's leading experts on qanats, said that the circles were definitely not qanats. Even the satellite images confirm this difference. Uh-oh, we were so close! Apparently, qanats or fogueras would not run down a straight line. They wouldn't be shaped like circles. Another clue that this wasn't the case was that there were no towns at the end. The circles were really far away from any human activity, and qanats were explicitly built to provide water for human settlements. Well, it sure was a good try. You almost gave up on this mystery when you decided to take one more field trip. It was days of preparation, pickup cars, food, equipment, all so that the mystery of the Sahara Circles could be unraveled. On the first day, you drove over 99 miles into the desert. You were always curious to see what this part of the world looked like. Over there, you see nothing but mustard yellow dunes. The night sky is pretty decent though. You can see the entire Milky Way with your own eyes. You set up camp and sleep under a canopy of stars. The next day, tension grows. There's no cell reception. Oh dear. But thankfully, you added the coordinates of the circles to your Google map. And surprise, the offline mode works out there. You follow the coordinates, but it leads you astray. You start to get nervous, thinking this was all in vain. But you and the team get into the car and drive a few more miles past the coordinates on your phone. After a very bumpy ride, you can't believe your eyes. There it is, an enormous crater dug on the sand, surrounded by 12 smaller holes. From up high, it looks like a clock, without the pointers, of course. On the ground, they're very faint, so faint you almost miss them. Searching the area, you notice all the holes had something similar, metal wires, thin wires that you can pull from the ground. They're buried deep, so you start digging. An object starts to reveal itself. Uh-oh, it looks like old dynamite. This certainly surprises you. Better stop digging to avoid any accidents. At the end of the survey, you feel satisfied, but still curious. What could all this dynamite mean? And who put it there? What comes next is the turning point of your adventure. Walking back to the car, you see something shining on the ground. You approach the item with curiosity. It's round and rusty and looks like a sardine can? What's that doing here? Could this give you more clues about the circle's mystery? Just in case, you pick it up and put it in the car. Back in the city, the puzzle pieces start to reveal the story behind the Sahara Circles. You bring photos and the sardine can and show them to local experts. They analyze your material and give you an intriguing verdict. As it turns out, guess number 1 was the closest one to the truth. So, what happened to the first guess? Why do we need to keep digging deeper? Well, because it was only half right. The Sahara Circles are not a historical footprint of seismic surveying. Back when the circles were made, this technology didn't even exist. But they sure are related to oil exploration. The dynamite-filled holes were an old method for oil searching. The circles are the leftovers of surveyors looking for resources underground. And the sardine cans? Well, they were left by the workers who held explosion works. You gotta eat, right? According to the model of the can, this happened more or less around the 1950s and 1960s. So these circles aren't even that ancient. More like modern ones, if you ask me. Well. Hope you are glad you tagged along and helped unravel this mystery. See you in the next mystery-solving adventure.
X-rays are a type of invisible radiation that can pass through our bodies and objects. They're very important in the field of medicine because they allow doctors to see inside our bodies without having to perform surgery. Now, let's dive into how X-rays work. They're a kind of electromagnetic radiation, just like light or radio waves. However, they have much higher energy than light, which makes them able to go through objects that light cannot. Imagine you have a powerful flashlight. If you try to shine it through a wall, the light won't go through because the wall is too thick. But these rays have enough energy to go through walls and even our bodies. The discovery of X-rays happened by accident in the late 19th century. A scientist was experimenting with cathode rays, which are a type of radiation. He was working in his lab and noticed that a nearby fluorescent screen started to glow, even though it was not directly exposed to the cathode rays. He realized that something invisible was causing the fluorescence, and he named it X-ray, because X is the mathematical symbol for something unknown. He continued experimenting with such rays and discovered that they could pass through many objects, like flesh and bones, but not through denser materials like metal. He also found that X-rays could create images on photographic plates, just like a camera takes pictures. The way this works is quite fascinating. Imagine you're standing in front of a bright light and you hold your hand in front of your face. Your hand blocks the light and you can't see through it. But if you place a sheet of tissue paper in front of your hand, some light will pass through, and you'll be able to see the outline of your hand. X-rays work in a similar way. When a doctor wants to take an X-ray of a part of your body, they will ask you to stand or lie down next to a machine. This device has a special plate that can capture the image. Let's say the doctor wants to further examine your arm. They will place the X-ray plate on one side of your arm and the machine on the other side. Then, the machine will produce a controlled burst of X-rays that pass through your arm. Remember how we talked about the tissue paper allowing some light to pass through? Well, in this case, some of those X-rays will go through your arm, while others will be absorbed or blocked by the denser parts of your body, like bones. The plate captures the X-rays that pass through your arm, and it creates an image. This image shows the bones and other structures inside your body, allowing the doctor to see if there are any problems or injuries. Now, you might be wondering why X-rays can pass through some things but not others. It has to do with the density and composition of the objects. Denser materials like bones absorb more X-rays, so they appear white in the image. So when you look at the result, you'll see your bones as white shapes. Other tissues like muscles and organs are less dense and allow some of those rays to pass through, so they appear as gray shadows. What if I told you there's a whole new way you can peek inside objects, but without using X-rays? I'm not talking about magic powers. Take a comfortable seat while I explain what mutography is. This fascinating scientific technique allows us to see inside objects and even beneath the Earth's surface using a special type of particle called a muon. These elementary particles are very similar to electrons, but they're much heavier. They are created high up in the Earth's atmosphere when cosmic rays, which are particles coming from space, collide with the air molecules. Now, muons are special because they can pierce through different materials. They can pass through rock, soil, and even buildings. Scientists realized this potential back in the 1950s when they were studying cosmic rays and noticed that some of the particles could pass through thick materials. The first muography experiments took place in the 60s. Specialists discovered that muons can be detected using special devices called muon detectors. These detectors are usually placed underground or in specially designed laboratories to shield them from other particles and background radiation. Now let's dive into how muography actually works. Imagine you have a large object, like a pyramid, a mountain, or even an ancient statue, and you want to see what's inside without damaging it. First, detectors are positioned around the object or in the area you want to examine. These detectors are sensitive to muons and can track their paths. When such a particle passes through a detector, it leaves a trace, like footprints in the sand. By collecting data from multiple detectors, scientists can reconstruct the paths. Here's where things get really cool. The Earth's atmosphere acts like a natural filter for muons. It turns out that the more massive an object is, the more particles it will block. So, if you have a large, dense object like a mountain, fewer muons will pass through it compared to a smaller, less dense object, like an empty box. This difference in the number of particles that reach the detectors can give us clues about what's inside the objects. Scientists use computer algorithms and mathematical techniques to analyze the data and create images. These images represent the density distribution of the object being studied. It's like creating a map that shows where the densest areas are and where there's gaps inside the object. The concept of muography is similar to using shadows to understand the shape and size of an object. Imagine you're standing in front of a bright light and you place your hand between the light source and a wall. You'll see a shadow of your hand on the wall. Based on the shape and size of the shadow, you can get an idea of what your hand looks like, even though you can't see it directly. This technique has been used to study various objects and structures. For example, scientists have used it to explore the inside of volcanoes and pyramids, and even to investigate the structure of mountains and the Earth's crust. With the help of this amazing technique, scientists have now uncovered new information about the Great Pyramid of Giza. They discovered something that had eluded tomb raiders for centuries. They found a hidden chamber. And guess what they named it? The Big Void. Yeah, I know, not the most creative name. They even used 3 different muon detection techniques just to be super sure that it was indeed a big, mysterious void inside the grandest pyramid of them all. Once news got out about this mind-boggling discovery, Egyptian authorities couldn't resist the temptation to explore further. So they brought in an endoscope camera to confirm the existence of this epic void. So they inserted a camera through one of the openings underneath the entrance, and voila! It revealed a corridor. More so, the corridor had a chevron ceiling. I can't help but imagine the ancient Egyptians using it as a cool dance floor. Another team of scientists decided to take another shot at scanning this newfound void. According to them, the Great Pyramid of Giza is a pioneer in the pyramid game. It used a technique called chevron to cover internal structures and keep them from collapsing. Now, why did the ancient Egyptians build this corridor and the grand void it leads to? One theory suggests that the corridor was built to relieve pressure inside the pyramid. Another theory says that the void could be a result of the pyramid's construction process. It could have been an internal ramp used to move roof blocks into position, and then it was left there or filled loosely with rubble. According to other enthusiastic explorers, there might be another burial chamber waiting to be discovered. They believe that the pyramids were built with a dash of randomness in the construction process. As the builders worked their magic, they realized that some chambers wouldn't be able to handle the weight of a majestic sarcophagus. So they made adjustments on the fly, creating new plans as they went along. A magnitude 15 earthquake has the potential to completely destroy our planet and evaporate all the water in a matter of seconds, leaving Earth uninhabitable. Over 500,000 earthquakes happen annually, but none have a magnitude of 15. 90% of quakes occur in the terrifying Ring of Fire zone located around the Pacific Ocean. The ground there is like jello. It shakes almost constantly. The most powerful earthquake to have ever struck Earth had a magnitude of 9.5. That much power can lengthen or shorten the day. But there's probably an earthquake in the confines of your own home now caused by a speck of dust landing on a table. But it has a power of negative 15 magnitudes. Earthquakes happen when tectonic plates move. They're like Lego pieces that are not properly secured, and when they move up, down, or hit one another, the ground also moves, triggering earthquakes. This tectonic energy acts like a battery. It stores energy for a long time, up to 500 years. When this stored energy is released in a sudden burst, the consequences are horrifying. Even the strongest structures submit to this relentless force that leaves a trail of destruction in its path. In some instances, earthquakes can even trigger tsunamis, amplifying the chaos. Such a crazy amount of power can split the ground open and cause severe damage. The strength of an earthquake is measured by the Richter scale, but now it's being replaced by the moment magnitude scale. When there's an earthquake, we hear about how strong it is. It's usually from 1 to 10. Luckily, we haven't had a Richter scale earthquake yet. The most powerful earthquake to have ever happened in modern history occurred in Chile in the 60s. It was around 9.5 on the Richter scale, and it altered Earth's rotation and messed up the length of the day by around 2 milliseconds. It also triggered a massive tsunami and affected a vast area of 155,000 square miles. The Richter scale doesn't actually have a limit. Still, anything above 25 doesn't need measuring, because if that ever happened, we would simply turn into dust, and nobody would care to measure this disaster. As we said, the strongest earthquake had a magnitude of 9.5. If this magnitude had been just 0.5 stronger, it would have created a ruptured line 2,174 miles long. That is almost 7 times the size of Wyoming. A magnitude 11 earthquake would create a crack halfway around the world. Massive tsunamis would hit coastal areas, destroying everything, and Earth would get into a massive environmental crisis. If you love hiking, you would have new mountains to explore, created by the terrifying earthquake. Even the temperature would increase because of volcanic eruptions and the resulting greenhouse gases. It would turn our planet into a hot oven. The safest places would be far away from any buildings, seas, oceans, and mountains where there would be a low chance of a landslide. Countries unprepared for earthquakes would be totally destroyed, and cities would turn into piles of rubble and dust. Going up on the Richter scale would only make things worse. But don't worry, an earthquake of that power is impossible. Earth's crust doesn't have enough energy to produce such earthquakes. But there is something that has much more power and can produce mega earthquakes. Asteroids are powerful enough to destroy our planet, as we all know from the dinosaur era. That asteroid was around 6 miles long and it caused massive damage to the planet. It triggered earthquakes that shook the ground constantly for months. These terrifying quakes were about 50,000 times stronger than the Chile earthquake. They also triggered a tsunami that was 30,000 times more powerful than the Indian Ocean tsunami. And the latter was one of the most devastating tsunamis to have ever struck Earth. The earthquakes caused by the asteroid had a magnitude of 11, making it the most powerful and scariest natural disaster ever. And let's hope it stays that way. The Indian Ocean tsunami affected only certain areas of the world. Meanwhile, the asteroid tsunami affected every part of the world and had 33-foot-tall waves. Even if you had traveled to the most remote place on Earth, you wouldn't have been able to hide from this Grim Reaper. A 15-magnitude earthquake wouldn't be 15% stronger than the Chile earthquake. The scale doesn't work like that. It would be around 100 million times more powerful than a 9.5 magnitude quake. It could make all the water on Earth evaporate, leaving us devastated and without any H2O to survive. All ecosystems would collapse, all food chains would be broken, and only some super strong bacteria would probably survive the impossible. That is only a fraction of the frightening things that could happen. The ocean is like the AC for our planet. Without it, Earth would be super hot. The ocean also serves as a shield from the sun's powerful rays. It acts as a heat absorber and cools Earth. Scientists think that the most dangerous thing would be the inability of Earth's crust to survive the violent shakes of the 15-magnitude earthquake. If our planet miraculously survived and didn't turn into dust, there would be massive openings in its crust. The ground would become gelatinous. It would randomly move up, down, left, and right, and no building would survive that. Our civilization would be brought back to the Stonehenge era. Tectonic movements like this are devastating. A similar thing happened in Japan when tectonic plates moved 165 feet from each other and then snapped back together, creating a 9-magnitude earthquake. No place on Earth is immune to this bone-chilling natural phenomenon. Still, certain places have higher chances of being destroyed than others, like the Ring of Fire, where 90% of earthquakes happen. This is a place where earthquakes are almost everyday occurrences. The Ring of Fire is located in the Pacific Ocean. It forms a ring around the continents that surround the Pacific. There, several tectonic plates meet, creating highly unstable ground. To make the problem much more terrifying, 75% of active volcanoes are located in this area. 90% of dormant volcanoes are also there, making this place extremely dangerous. Scientists carefully study this region to find a way to predict when the next earthquake might strike. The Ring of Fire is not the only place at risk of earthquakes. In California, along the San Andreas fault line, 2 tectonic plates have been storing power for more than 200 years. The San Andreas fault is 715 miles long and has the potential for a massive earthquake. This region has its fear of violent earthquakes like the one that happened in San Francisco in 1906. It had a magnitude of 7.8 on the Richter scale. Scientists' predictions are terrifying. They say that the chance of a 6.7 magnitude earthquake is very high in the area. If all hell starts to break loose, you should know how to survive. Avoid anything that might fall on you, like windows, closets, or unstable ceilings. The official phrase from emergency experts is drop, cover, and hold on. Stay low to the ground. Hide under something stable like a table, and remain there until the shaking stops. Make sure to stay in your shelter for another minute or two, just in case there are aftershocks or loose debris. Use your nose and smell for gas. If you do smell it, don't turn the lights on or do anything that might ignite it. Stay strong and be safe. On January 26, 1700, one of the biggest earthquakes in history hit off the coast of the United States. It had a magnitude of 9, which puts it in the top 10 most powerful earthquakes ever recorded. This earthquake triggered a huge tsunami and changed the coastline all the way from southern British Columbia down to northern California forever. Back then, the area wasn't very populated, but thanks to some clever research, scientists figured out exactly what happened that day by looking at old geological records, tree rings, and even some history from Japan. On the same day as the earthquake, a massive tsunami also hit Japan's eastern coast. For a long time, no one connected the two, but in the 1980s and 90s, researchers realized the tsunami in Japan had been caused by the earthquake in the Pacific Northwest. They were also able to pinpoint the exact day, January 26, 1700. They even found old trees in coastal Washington that had all perished around the winter of 1700, which matched up perfectly with the timing of the earthquake. The earthquake came from the Cascadia subduction zone, a fault where the Juan de Fuca plate slides under the North American plate. This fault stretches about 700 miles, from northern Vancouver Island in British Columbia to Cape Mendocino in California. The pressure from the moving plates builds up over time, and eventually, another big, devastating earthquake will hit the same region. It's just a matter of time. By looking at the geological records, past tsunami deposits, and signs of land level changes, scientists can figure out how often these huge earthquakes happen. Emergency planners have been preparing for the next big quake, often calling it the big one. Scientists believe earthquakes in the Cascadia subduction zone happen every 200 to 1,000 years. And since the last major one was over 300 years ago, the Pacific Northwest is definitely due for another. When it happens, the earthquake is expected to be as big as the one from 1700. But this time, it'll affect around 15 million people. The devastation will be severe. Buildings will collapse, roads and runways will crack, and bridges will fall. Communication in and out of the area will be cut off. But the worst part? The earthquake will trigger a massive tsunami that might hit parts of the Washington coast in as little as 10 minutes. It's not a matter of if, but when the Cascadia subduction zone will break. When it happens, it will be the worst disaster the US has ever faced. Worse than the Hurricane Katrina or Superstorm Sandy. It'll impact an enormous area, stretching from southern British Columbia all the way down through Oregon to northern California. That means millions and millions of people will be affected. Fairchild is considered a backup staging area for handling the aftermath of the earthquake, with Grant County International Airport in Moses Lake being the main one. For those who will survive the initial quake and tsunami, the aftermath could be just as disastrous. Aftershocks will follow, and transportation will be a mess. Roads will be damaged or completely blocked, airports will shut down, and most of the main routes, like Interstate 5, will have bridges destroyed. This means food and water supplies will be cut off, and it will be incredibly difficult for help to get in or for people to escape. Gas pipelines will most likely be damaged too, and restoring them could take anywhere from a few days inland to weeks or even months along the coast. Power outages will be widespread within 100 miles of the coast throughout the entire Pacific Northwest. And water could be out for 3 to 7 months. Even telecommunications will be down for 2 to 3 months across the Pacific Northwest, Alaska, and even parts of East Asia. The good news for eastern Washington is that it will mostly avoid the worst of it. thanks to natural barriers between the west and east sides of the state. The tsunami may hit the Columbia River Gorge, but it will lose energy quickly because of a sandbar under the river. The Cascade Mountains will absorb much of the earthquake's impact, so the east side won't feel it as strongly. And since eastern Washington won't get hit as hard, it'll be up to them to handle the aftermath of the quake. That means helping western Washington, taking in refugees from the areas that got destroyed, and delivering supplies to where they're needed. Scientists have looked at other major 8.0 to 9.0 magnitude earthquakes like the ones in Chile in 1960, Alaska in 1964, and Sumatra in 2004, and Japan in 2011. These kinds of quakes can shake the ground for anywhere between 6 to 10 minutes, and that's a long time for the ground to be shaking. Such quakes are super intense because they happen close to Earth's surface, so it's not just a quick shake. It's a long, strong one that can cause a lot of damage. If the Cascadia earthquake and tsunami were to hit tomorrow, over 13,800 people could lose their lives, and about 107,000 people could be injured. The economic toll in Washington, Oregon, and California could top $70 billion. To put that into perspective, we can compare these numbers with some other major earthquakes. In Chile's 1960 earthquake, about 1,650 people lost their lives. The 1964 Alaska quake resulted in around 140 lives lost. The 2004 Sumatra earthquake and tsunami took the lives of an estimated 280,000 people. And the 2011 Japan earthquake and tsunami caused over 20,000 casualties. Authorities know about the dangers of the Cascadia Fault, but even with all the planning, no one can say for sure what will be needed when the big quake hits. Right after the earthquake and tsunami, the areas outside the immediate disaster zone won't be able to help much because roads and airports will be destroyed, and resources will be limited. How can we deal with this kind of disaster and its effects? We don't have all the answers yet. Right now, let's focus on the Cascadia subduction zone. It's a huge fault line that stretches about 620 miles from Vancouver Island to Cape Mendocino in California, sitting about 93 miles off the coast. It's like one tectonic plate is slowly sliding under another. When the plates are close to the surface, about 18 miles deep or less, they get stuck because of friction, kind of like pushing two rocks together. Over time, this creates a lot of pressure. When the pressure finally becomes too much, the plates slip, causing a massive earthquake. This is called a megathrust earthquake, and it can be huge. Below the area where the plates are stuck, there's a zone where the plates move really slowly. We're talking about just a few inches every few months. This slow movement helps to release some of the pressure, but it also builds up more pressure on the parts of the fault that are still stuck. This means that over time, it increases the chances of a huge earthquake happening. These massive quakes, called Great Subduction Zone earthquakes, can be stronger than magnitude 8.5. Megathrust earthquakes are the biggest earthquakes that happen. They can go over a magnitude of 9.0, which is insanely powerful. Just to put it in perspective, a magnitude 9.0 earthquake releases 1,000 times more energy than a 7.0 and 1,000,000 times more energy than a 5.0. These earthquakes happen when a lot of pressure builds up in a part of the fault that's locked, which means the plate can't move past each other. When that pressure gets too high, the fault finally ruptures, releasing all that built-up energy in one massive shake. The Cascadia subduction zone is super long. That's why if it were to rupture all at once, it could produce a large earthquake. Scientists have studied this region and found that about 18 miles below the surface, the fault is completely locked. The plates there aren't sliding past each other. But deeper down, the plates start to slide more smoothly, causing less friction. This is important because it tells us how much stress is building up in that locked zone, and how it could eventually lead to a major earthquake.
So, since 2000, the world has been hit with more than 1,700 earthquakes with magnitude greater than 5. Many happened around the Ring of Fire, located around the Pacific Ocean. In North America, the biggest threat is the San Andreas fault line, which can create an earthquake of a magnitude higher than any other, earning it the spine-tingling nickname, the Big One. The potential destruction of California is a terrifying prospect that could have unimaginable consequences. But the Big One is just the beginning of what's to come. Bad news! Scientists have predicted an earth-shattering event that will occur in 2030. Like it or not, there's a 70% chance that we'll experience the Big One, and it will be an earthquake with a magnitude of 6.7. The San Andreas fault line will cause the Big One, but what is scary is that we can't predict it. On the other hand, a massive earthquake occurs every 100 years. This means there's always time to prepare for a natural disaster. If we traveled back in time, we'd see a few significant earthquakes like the ones that wiped out San Francisco and Fort Tajon. Buildings made a long time ago are not quake-proof. They will collapse. Even if they survive, you should not enter them. But buildings are not the most dangerous part. You should watch out for electrical lines and gas pipes. Your hill house might be lovely, but it is extremely unsafe. During quakes, the hill can turn into a massive landslide that will destroy everything in its path. Say goodbye to road trips because all the roads will be ruined. You should have some spare water and food since you won't be able to go to the supermarket. This disaster won't be cheap. It will cost the U.S. around $200 billion to recover from the quake. At least the earthquake will not trigger tsunamis. But there's something that can cause more damage than the Big One. The notorious Cascadia subduction zones start in California and ends up all the way in Vancouver, Canada. The San Andreas fault line is nothing compared to this zone. It can wipe the whole coast off the face of the Earth, an example of hyperbole. Subduction zones are tectonic plates forced to be one under the other and constantly pulling apart. One is called the North American Plate and the other is the Juan de Fuca Plate. Zones like these are not to be messed with, since they are terrifying hotspots for earthquake activity and extremely dangerous because they cause massive underwater quakes. But they are underwater, so what can they do to us? Well, they can cause giant tsunamis, flooding cities, and destroying the coastline. Right now, the most active zone is the Ring of Fire. The Cascadia zone might be less active, but it is like a sleeping beast that can wake up and destroy everything in its path, causing a groundbreaking earthquake. The last time all this stress was released was in the year 1700. Unlike the San Andreas quake, this one will cause massive tsunamis and much bigger shocks. Let's hope you'll be camping in an open field at that time, because most buildings and bridges will likely be destroyed. Also, be ready for the aftershocks, as they'll be devastating. Nature won't be spared either. Landslides will change animals' habitats. Even our homes will be changed forever. Luckily, there is a light at the end of the tunnel, and scientists are doing everything they can to ensure our safety. New rules are implemented. Every new building must be able to withstand massive shocks. They're developing modern warning systems, and every new infrastructure must follow strict quake-proof guidelines. The Juan de Fuca and the North American plates are locked together, but they won't stay like that forever. When they unlock, get ready for a massive shake. The closer you are to the epicenter, the more damage you'll experience. But even if you are lucky to be far away, you may still feel the ground shaking for some time. Now, if we compare the Cascadia subduction zone and the San Andreas fault, we'll see how much more dangerous the Cascadia zone is. In 1994, there was an enormous 6.7 magnitude earthquake in the Northridge area, close to the San Andreas fault. Sadly, many people didn't make it, and some were injured. Back then, buildings were not strong and earthquake-proof, and many of them were damaged. The Cascadia subduction zone can potentially cause a magnitude 9 earthquake. A magnitude 6 quake has the power of around 44 million pounds of dynamite, but a magnitude 9 has the power of 44 trillion pounds of dynamite. The strongest ever recorded quake was in Chile. Its magnitude measured 9.5, and it destroyed most everything. So let's say you've survived the quake, but the struggle is far from over. Soon after, a massive tsunami will strike, with waves that might reach up to 100 feet in some areas. That's so unlike the San Andreas earthquake, which can't produce any significant waves. So say goodbye to your beautiful garden, since salt water will destroy trees and plants, changing the environment for a period of time. The only positive thing will be you won't need Halloween decorations, because all those dried out trees will resemble a ghost forest. The combination of waves, quakes, and the sheer size of the area will make this natural disaster much more dangerous than any caused by the San Andreas Fault or the so-called Big One. A quake similar to this happened around 300 years ago. Many more have been recorded in the past 3,500 years, proving that they continually occur every 400 to 600 years. So, technically, we have around 100 to 300 years before the next big one hits. We still have no idea how exactly the Cascadia subduction zone works, because we discovered it in 1970. This zone is super scary because it can cause big earthquakes. It was found by accident when researchers studied the Ring of Fire. They wanted to know if this area had caused any trouble in the past years, and the proof was under their noses. In Washington, there is a horror forest where nothing has been growing for years. When researchers tested the soil, they found a tremendous amount of salt. They put two and two together and concluded that a massive tsunami had been the reason. Experts still didn't know when the forest was destroyed. But Japan kept records of a gigantic earthquake that had a similar effect. It was the one that happened in the year 1700. There is a 1 in 3 chance that the next one will occur in 2050. You must know how to survive the Canadian earthquakes and make it out unscathed, so listen carefully. Those who live in this area have almost no experience with earthquakes like this one. Surviving the quake is relatively easy, but the tsunami coming afterwards is the real danger. After the shake, find the highest ground and go there. Only bring the essentials, like food and water. Yeah, leave your baseball card collection at home. After the first hit, don't try to go down. Seismologists say that most likely there will be a few more waves, and they have proven this. On the 22nd of May, 1960, seismologist Jerry Eston and his 4 friends went to Hawaii to see an expected tsunami that was to happen around midnight. They set up their gear on Wailuku Bridge with an escape route planned. This bridge had been destroyed in the previous tsunami, but the new one was much taller and better. After midnight, the water was 4 feet above the average level. The second wave hit a half hour after midnight, and the water rose another 9 feet by 1 a.m. The water started going down and dropped by 7 feet, but the horror was far from over. Next, they saw a wave that was around 20 feet tall. This shows us that tsunamis are unpredictable, and we should listen to experts to stay safe.
An earthquake in Indonesia began in 1829 and lasted a mighty 32 years. It reached its climax in 1861 and hit a magnitude of around 8.5. It was caused by the tectonic plates below the island slowly clashing against each other. Researchers discovered that the quake had been building for some time after analyzing the coral in the area. They found it was being periodically exposed to the open air. That was caused by the gradual earthquake moving the land up and down. Scientists call these decades-long silent earthquakes slow slip events. A single lightning bolt can warm the air to around 54,000 degrees Fahrenheit. The heat makes the air expand quickly, creating a shock wave or boom, which we know to be thunder. There are close to 3 trillion trees on Earth. That translates to roughly around 422 trees for every person. Before humans, the number was nearer to 6 trillion. Almost 70% of the Earth's surface is covered by water, which on average is around 2.5 miles deep. 97% of Earth's volcanoes lie underwater, as well as the mid-ocean ridge, a massive mountain range that is over 40,000 miles long. Humans have mined around 190,000 tons of gold from the planet. Experts predict there is around 20% still left to be mined, but this figure is constantly changing. The world's largest active volcano is in Hawaii. Called Mauna Loa, It's over 2.5 miles above sea level. Given that most of it is underwater, the volcano's summit is a staggering 11 miles from its base. That's the same length as over 160 football fields. The highest ever recorded temperature on Earth was a sweltering 136 degrees Fahrenheit. It was recorded in El Azizia, or modern-day Libya, on September 13, 1922. The lowest temperature was a chilling minus 129 degrees Fahrenheit, recorded at Russia's Vostok station in 1983. Earth is the fifth largest planet in the solar system, behind Jupiter, Saturn, Uranus, and Neptune. It has a circumference of roughly 25,000 miles, and it would take the average person around 8,300 hours to walk around the face of the Earth. The separation between Earth's land masses would make such a trek almost impossible, though. It takes 365.25 days for the Earth to orbit the Sun. Because our calendar years only have 365 days, we add an extra leap day every 4 years to make up for the difference. Russia is the largest country on the planet, with a total area of about 6.5 million square miles. It encompasses more than 1/8 of the Earth's inhabited land area, but still has a relatively small population given its size. Earth is the only planet with one moon. Mercury and Venus have no moons, while every other planet has 2 or more. Earth is over 4 billion years old. Scientists calculate this by looking at the planet's oldest rocks, as well as meteorites that have crash-landed. They used meteorites as they were formed at the same time as Earth, when the solar system was forming. The ground we walk on is basically recycled. The planet's rock cycle turns igneous rocks to sedimentary ones, then transforms those into metamorphic rocks, and back again. Like Earth, our moon also experiences earthquakes. They're less common and intense than the ones we have, and are caused by tidal stresses. A tidal stress is basically the relationship between the gravitational pull of the moon on the Earth and that of the Earth on the moon. Despite being the fifth largest continent, Antarctica holds 70% of the planet's fresh water and about 90% of its ice. Bangkok is the most visited city in the world, boasting 23 million visitors in 2019 alone. Paris, London, Dubai, and Singapore make up the other cities in the top 5. The lowest layer of Earth's atmosphere is called the troposphere and is the reason we have weather. Sunlight heats the planet's surface, which causes warm air to rise up to the troposphere. This air then expands and cools as the air pressure decreases and sinks down, where it is then warmed by the Earth again. Coral reefs are the largest living structures on the planet, with some even being visible from space. Coral reefs hold the most species per area of any of Earth's ecosystems, even more than rainforests. Earth got its name around 1,000 years ago, and it comes from the German word meaning the ground, but there's no evidence to show who actually named it. Of all the planets, Earth is also the only one which is not named after a Greek or Roman deity. The deepest point of the ocean is the Mariana Trench. It's a whopping 7 miles below sea level. Coastlines cover about 20% of U.S. land, but are home to more than 50% of the U.S. population. The Earth isn't actually a sphere. It's more like a squished ball that bulges at the equator. The bulge is caused by the force of the Earth spinning, which makes the north and south poles slightly flat. The Earth spins on its axis, which is basically an imaginary straight line. Earth has seasons because the axis is tilted, causing the sun's rays to hit different parts of the planet more directly, depending on the time of year. If the sun was as tall as a standard door, the Earth would be around the size of a nickel. The Earth's rate of rotation is gradually decreasing. It's happening so slowly that it would take as much as 140 million years for the length of a day to increase to 25 hours.
Get equipped for any season with brand new Brightside merch. Click the link and grab your print.
The biggest animal on Earth is the Antarctic blue whale. It can reach lengths of 100 feet and weigh up to 400,000 pounds. which is around the same as 33 elephants. The temperature at the center of the Earth is around the same as the surface of the Sun, at almost 10,000 degrees Fahrenheit. Earth is around 10,000 times older than humans. Earth is around 4.5 billion years old, whereas humans have been around for, at most, 450,000 years. There are around 34,000 known species of fish. The actual number is way higher though, as a whopping 95% of our oceans still haven't been explored. America's Route 66 is longer than the journey to the Earth's core. The distance to the core is roughly 2,000 miles. Route 66 is almost 2,500 miles. The Earth is made up of three main components: the crust, the mantle, and the core, which is divided into the outer core and the inner core. Scientists have estimated that there are around 8.7 million species on the planet. Out of this, between 1 to 2 million of these species are animals. But roughly 86% of land species and 91% of fish have yet to be discovered by humans. Ancient astronomers used to think that the Earth was the center of the universe. For 2,000 years, they believed the Earth to be static, while other bodies traveled in orbit around us. In 1543, Copernicus published his sun-centered model of the solar system. Earth is the densest planet in the solar system. The density varies across its different crusts, but the planet's average density is just over 3 ounces per cubic inch. Mount Everest is the highest point on the planet. Its peak is the highest altitude above sea level at around 5.5 miles. Each year, 1 septillion crystals of snow fall on Earth. That's a trillion snowflakes. Snow covers about 31% of Earth's land area each year. Of Earth's water, only around 3% is fresh water. The other 97% is salted. Of that 3%, about 2% is frozen in ice and glaciers. So, less than 1% of the planet's fresh water is actually in lakes, rivers, and underground. The world's largest inland body of water, or lake to us normal people, is the Caspian Sea. It has an area of 140,000 miles squared. The world's deepest lake is Lake Baikal in Russia and is 5,300 feet deep. Earth's atmosphere is roughly 78% nitrogen and 21% oxygen, with small amounts of water vapor, carbon dioxide, and other gases. No other planet is believed to have this much oxygen, which explains why Earth is the only planet where life has been discovered so far. Apart from the Moon, there are 2 asteroids in co-orbital orbits with Earth, sometimes called Earth's second moon. 3753 Cruithne is an asteroid that looks like it's following the Earth in orbit, but it's actually following its own path around the Sun. 2002 AA29 is another asteroid which makes a horseshoe orbit around the Earth that draws it close to the planet every 95 years.
You have friends over for dinner. You set your drink on the counter and go help your friend set out some desserts. When you get back, you notice the liquid in your cup. It's sloshing around and the ice cubes look like ships on a rough sea. Now you feel it too. On the ceiling, the chandelier is swinging like mad. Then you hear someone scream, "Earthquake!" The house and everything in it is rocking back and forth. You try to run for cover, but the shaking keeps you stuck in place, fighting to keep your balance. The cabinets look possessed, and glasses and dishes fly out and smash on the floor. The bookshelves topple over, and everything hanging on the walls sways and falls off. You duck under the dining room table, trying not to get hurt on all those broken dishes. Yeah, you've been through earthquakes before, but none like this. Checking your phone? Typical, no signal. You can't believe what's about to happen. The screams get louder, and suddenly, the whole house collapses. The biggest earthquake ever recorded happened in Chile in 1960. Disaster came in the afternoon, just when everyone was out enjoying themselves. To cause serious, life-changing damage, you need to have a magnitude of around 7 or so on the Richter scale. This one was 9.5. This part of Chile is smack dab on the so-called Ring of Fire, the most active volcanic and seismic area in the world along the Pacific Rim. The initial shaking lasted around 10 minutes, and after 2 days, many aftershocks were still strong enough to set off a volcano in the south of the country. But that's not where it ended. The earthquake unleashed a series of tidal waves all over the Pacific Ocean, with some reaching over 80 feet high. The waves and earthquake were so strong that they even affected Hawaii, Japan, and the Philippines. It caused around $500 million $1960 worth of damage. Many were left homeless. Much of their infrastructure was smashed too. Buildings as far as the eye could see were toppled, and debris piled everywhere. Scientists estimate that this earthquake was so powerful, it shifted the Earth's axis, making our days 1.26 microseconds shorter. That might not seem like a lot, but think about it. Just one natural disaster was strong enough to make time move. Many of the coastal cities were flattened and floods were widespread. The economy spiraled downward. According to studies, if this earthquake happened today, it caused more than $20 billion in damages. So, what would happen if an earthquake twice that size hit without warning? For starters, you'd likely feel the effects even further away. Tidal waves wouldn't just hit the coasts of Japan and the Philippines. They would move even further to China, Korea, Vietnam, and even Australia. And those waves would be significantly higher than 80 feet, perhaps double that. That's like 8 giraffes piled on top of each other, surfing your way. If you lived by the coast, you'd notice the waves. If you saw the water recede way back so you could practically see where all the fish call home, you'd know it was time to run. Chances are that a tsunami's heading your way. Say it really happens. You're caught under the wreckage, not knowing what's going on. You manage to free yourself and escape to the fresh air. And you're not alone, because all the houses in the neighborhood have turned into piles of bricks and rubble. The bridges have also collapsed, leaving people stranded on either side. You look around, dust yourself off, and rush to find help. Fire trucks and ambulances drive between the broken-down cars and rubble. You try to make it to your car, but the aftershocks are still hitting, and you're getting tossed to the sidewalk. With all the cell towers down, you can't call anyone on your phone. Your knees are shaking, but you manage to power through. Once you reach your car, you see it crushed under a boulder, like a giant soda can. You continue on foot and eventually reach downtown. It looks as if some giant got angry and knocked all the buildings down. You push forward and try to see if you can find some help. Without warning, your phone vibrates. You check it and see 1,000 notifications about a 20-magnitude earthquake. You're still shaking, but that's all you. The ground is still for now. Uh-oh. You hear something in the distance, racing towards you. To your right, you see tidal waves as tall as buildings charging at you. Still in shock, not knowing what to do, you now come to your senses and run. You don't even know which way to go. There's a tsunami right behind you, and in front of you are broken down buildings with rocks and concrete still falling everywhere. Wait, there's a building that's somehow still standing. You need to get on top of that thing. You reach the elevator, but it's jammed. Not surprising. You bolt up the stairs as fast as you can, tripping on broken glass and plaster, but always managing to get back up. You look out a window and see the water. It's so close. You're nearly at the top. A few more flights and whoosh. The water forces its way into the building and drags you down at least 2 floors. You can barely see anything. Still, you know you must swim up. But the water keeps forcing you downwards. After about 30 seconds, you manage to swim your way out and continue climbing to the top. You scramble to the top floor and collapse on the roof. You're safe for now. The tidal wave is still going strong, plowing its way through the ravaged city center. Your phone is now waterlogged and useless. You have a perfect 360-degree view of your town covered in water and debris. The ground starts to shake again. Maybe you'll just sit around until this is all over, waiting for the rescue helicopter. But then, a loud explosion that almost breaks your eardrums shakes the ground even more. Off in the distance, smoke is rising, and soon it covers the entire sky. Darkness hides the morning sun. That's when you can see lava shooting up into the air and landing nearby. The lava forms into a river, flowing its way into town block by block. With this much seismic movement and the high intensity of the earthquake, the world's tectonic plates have shifted so that magma is pushing its way to the surface. From the earth, steam begins to vent. Then the heat hits you. You see the magma cover the ground like a blanket, eating up every car in its way. What's worse is that the magma is melting the foundations of the buildings that managed to withstand the earthquake and the tsunami. The buildings in the distance are now sinking and collapsing into the raging lava pool that's replaced your town. One by one, every building descends. That means, the building where you're standing is also swaying. It's about to fail. That's when you see the light. You look up and see a helicopter above in the distance. You wave your arms, run around, jump, anything to get noticed. And it works. The chopper makes a few circles and finally drops you a rope ladder. As you're lifted in the chopper, you take a good look at the world below you as it wriggles around like noodles in a strainer. You land a few miles out and are immediately treated by a doctor in an emergency triage center. You were one of the lucky ones. A year later, the tsunami water has receded. The lava that flowed inland has cooled, but all that magma permanently changed the ground below it, and the whole town is gone. The disaster has thrown the entire country into a financial nightmare that'll last decades. It takes months to survey the town, making sure there's no dangerous electrical wires or busted gas pipes anywhere. They're rebuilding your town farther inland from where the old one was. In other towns, they rebuild directly over the ruins. In others, they just decide to move everyone to a nearby city. There is a powerful force hiding underground where tectonic plates meet, and one forces another under it. This happens in the Pacific and Indian Oceans. Strain builds over centuries. The tension is unbearable until the megathrust awakens. The Earth shakes with a magnitude that can exceed 9 points, more powerful than any other earthquake. When the seafloor suddenly gets pushed up fast, it sends a huge ripple across the water, and a tsunami of huge force is out. These waves are called teletsunamis, and they cross entire ocean basins, ready to take over coastlines thousands of miles away. The thrust fault stretches over 600 miles. The Earth is not just shaking, it feels like it's tearing apart. This is the power of a megathrust earthquake. Those caught in its path will have to fight for their lives. Japanese authorities recently had to issue their first ever megaquake advisory. It happened because of a strong tremor on the edge of the Nankai Trough ocean floor zone. In the end, most of the warnings were lifted, and there wasn't much damage from the 7.1 magnitude earthquake. Parts of southwestern Japan started to shake, and the superfast trains in Japan slowed down to stay safe, which made travel slower for everyone. But everyone is staying alert as they know about the risk of a megathrust earthquake that could happen within the next few decades in the Nankai Trough. The tectonic plate under the Philippine Sea is slowly sliding underneath the land where Japan is, moving just a few inches every year. The last big earthquakes from this area happened in 1944 and 1946, both with a magnitude of 8.1. These quakes have caused a lot of destruction in the country. The next megathrust earthquake in the region, if it does happen, could be between a magnitude 8 and 9. Scientists still can't agree on how likely this mega earthquake is to happen, but it could be up to 80% certainty. On the other side of the Pacific, scientists from the U.S. Geological Survey have studied a dangerous area along the U.S. West Coast. It's called the Cascadia Subduction Zone, and it stretches from northern California to northern Vancouver Island in Canada. Over the past 14,200 years, there have likely been at least 30 big earthquakes in this region. One major quake happens every 500 years on average. But for a long time now, Cascadia has been quiet, and it worries scientists. They think this might be because the area is locked, meaning the tectonic plates are stuck together and building up a lot of pressure. Eventually, the part of the seafloor could suddenly break and move by several feet. The shaking would be just 5 minutes, but it would create a powerful tsunami as the seafloor shifts that would last for 10 hours. If it happens, it's going to be the worst natural disaster in the country's history, according to experts. The ground on some inland hills could turn into something like quicksand. This would cause the hillsides to slide and crumble, taking down roads and bridges. Around 620,000 buildings could be badly damaged or even collapse, including about 100 hospitals and 2,000 schools. People in Washington state might have to take care of themselves without help for 2 weeks, finding food, water, and shelter on their own. Scientists are studying slow slip events, where the tectonic plates move very slowly over weeks or months, releasing some energy but not enough to stop a big one. Every time the magnitude of an earthquake goes up by just one number, the energy it releases is 40 times bigger. So we'd need about 1 million small earthquakes every day for 500 years straight to release the same energy as one huge magnitude 9 earthquake. But these small earthquakes might be clues that a bigger earthquake is coming. To better monitor the Cascadia Fault, experts are mapping the fault more accurately and adding better monitoring tools offshore. Scientists receive over $10 million to install seismic sensors and seafloor pressure gauges on a fiber optic cable off the coast of Oregon. The goal is to be ready to warn people and potentially save lives when a big earthquake strikes. A sharp megathrust earthquake happened in this part of the world in 1964. It went down in history as the Great Alaska Earthquake and had a magnitude of 9.2. It lasted for more than 4 minutes, making it the most powerful earthquake in the history of the U.S. and North America. The ground shook so hard that it caused huge cracks and landslides. In Anchorage, many houses, buildings, and roads were destroyed because they weren't built to handle such a big earthquake. In some places, the land was permanently changed. For example, the coastline near Kodiak and Hinchinbrook Island was lifted by 30 feet. In other areas, like Gerwood and Portage, the ground sank by 8 feet. They had to rebuild roads higher so they wouldn't be flooded by the tide. A huge 27-foot tsunami wiped out the entire village of Chiniga. Many coastal towns were heavily damaged, not just by the earthquake, but also by tsunamis and the fires that followed. After the main earthquake, there were thousands of smaller aftershocks for months. A moderate earthquake of magnitude 4.4 shook Los Angeles in August 2024. Once it was over, the LA Fire Department checked around the city and didn't find any major damage or anyone hurt. In the nearby city of Pasadena, which is close to the earthquake's epicenter, a water pipe burst inside City Hall and everyone had to leave the building. Thankfully, there was no danger of a tsunami. The best we can do to avoid panic in such situations is to be prepared. Japan is one of the places on Earth where earthquakes happen the most because it sits on the edges of 4 tectonic plates. Around 1,500 of these earthquakes each year are noticeable. Because of this, the people in Japan have learned to live with earthquakes. The 1950 law set a rule that buildings should be able to handle earthquakes up to a magnitude 7 without falling apart. An update 30 years later said that buildings should only have minor damage in such earthquakes and still work as usual. But if an earthquake is even stronger, the law says the building's main job is to not collapse and save people's lives. At the most basic level, buildings are made stronger with thicker beams, pillars, and walls so they can handle shaking better. Another technique is placing special pads made from materials like rubber at the base of a building. Some buildings are even built on thick layers of padding that separate them from the ground completely, which helps protect them during an earthquake. A skyscraper might sway back and forth a lot, moving up to 5 feet. To stop it from getting damaged, engineers can add something called dampers every second floor all the way to the top. These dampers are like giant bicycle pumps, but instead of air, they're filled with liquid. When the building shakes, the dampers push against the liquid inside them. Even though the liquid doesn't squish very much, it can still absorb some of the shaking. When they're building tall skyscrapers, engineers try to make the structure as simple and balanced as possible. This means having each floor the same height and placing the support columns evenly. But sometimes, architects who design skyscrapers don't want to make these compromises because they have creative ideas for how the building should look. Then they have to find compromise solutions. For example, Tokyo's Skytree Tower, one of the tallest buildings in the world, is designed in a futuristic style but also includes special features to protect it from earthquakes. It has a central pillar, like in traditional Japanese pagodas, and seismic dampers that help absorb the energy from an earthquake, keeping the building safe.
You rub your eyes, trying to make sense of everything. Perfect circular holes in the bottom of the ocean floor off the coast of Big Sur in California. You have no idea how this happened, even though you're a marine biologist who's been practicing it for years. You go through some of the old records and find out that these holes have been around since the 90s. In 1999, a ship-mounted sonar conducted a survey and found 5,200 of these pockmarks, or large holes over 500 square miles, on the ocean floor. They look like moon craters underwater. You contact your team and get the robot ready to go down and explore the scene and bring back a few samples. You and the team drive to the coast and hop on the boat. You're sitting inside controlling the robot with a joystick. Your teammate sets the robot in the water and drives it down. Everything seems normal near the surface, but as the robot goes lower, the pockmarks start appearing. A bunch of boats swift past you, making you lose your balance and focus. The robot turns on the flashlight so you can see better. But as it goes lower, the resolution is less crisp. It almost reaches the bottom, and the holes are smooth and nearly perfect circular shapes. Some of these holes that were visible in the sonar reading measure more than 30 feet across and 15 feet deep. You show the rest of your teammates the images, and they're shocked. The robot continues swimming, but there appear to be more holes all around. Many of them are too small for the scanner to capture from above. These microdepressions are steep and have sort of tails going in a certain direction. It's possible that the currents underwater played a role in their shape. Everywhere the robot swims, there are new holes all around. After a couple of hours, the robot goes back to the boat with some samples. You take them back to the lab and study them. The robot clearly captures images of human trash, but the samples don't indicate anything alarming for now. Despite the fact that 1/3 of the pockets are filled with trash, there's still no explanation of how they were formed. It's late at night and the rest of your team heads back home. You're passing out in the lab, still trying to find some answers. You wake up the next day, and while cooking breakfast, you get this idea that maybe these holes are gases venting out, which could be harmful to marine life. You quickly get the robot and sail out to the ocean once more. This time, you didn't even think about calling your teammates. You place the robot in the water and get behind the screen to control it. The robot descends to the bottom of the ocean and does a survey. So far, the holes still seem to be covered with trash. But some of the holes have marine life dwelling inside, like fish and seaweed. After much scanning, it doesn't look like they're producing any bubbles, which means there aren't any gases venting out, but you're determined to find them. After a while, you reach one of those large pockmarks, and the robot starts scanning around. You find some bubbles coming from a source, but the robot can't reach it. It swims around trying to find a spot, but nothing. You bring the robot back to the lab and work on it. You attach some mechanical arms on it that can lift things and move them. You bring the robot back down to the same spot, but the bubbles aren't as frequent as before. You use the arms to move some of the trash and find out that the bubbles are being produced by a group of crabs chilling next to a pile of plastic. Bingo! The bad news is, you still don't have a clue why the microdepressions and pockmarks exist. As you try to control the robot to go back to the surface, an octopus wraps its tentacles around it, pulling the robot down. You struggle with the controls and push it to maximum power, but the suctions of the octopus are too strong to break off. It's a game of tug-of-war with the octopus and your robot. It takes the robot under a pile of trash, thinking it's lunch. But you use the arms to maneuver the robot out and swim back to the surface. You go back to the lab even more confused. The robot has collected more samples for you to study. Your eye is glued to your microscope, trying to figure out what's going on, but nothing. You decide to do a carbon dating test to determine how old these holes are. After a while, you check out the results and are even more stunned than before. They show that the holes are around 400,000 years old, so it's likely that human trash wasn't the cause for all this. You pull many all-nighters trying to figure out the truth. You gather your team once more and hold a small press conference about this. You claim that this may be something we should be extremely worried about, but you still can't tell them more than what you know. With all the brain work put together, you find out that the large pockmarks haven't changed or been active for more than 50,000 years. The newer holes were most likely created by human trash settling in the bottom of the ocean floor. The marine life gathered some of this trash like plastics and discarded fishing gear and created homes for themselves. This is why around 4,500 of the holes are newer and have trash in them. But it still doesn't answer why the holes appeared in the first place. You're back to square one. The only way to see what's really going on is to clear up the trash from underwater and study them. The story makes headlines in the local community and catches the attention of a cleanup crew. You organize a trip to the ocean and begin the extraction of all the trash. Many cleanup boats arrive and everyone drops down a net to collect the trash. You send down the robot once more to make sure the nets are hitting the right spot. As most of the trash is being collected, many marine life animals scramble and try to find a way to escape. Everyone makes sure not to hurt them. After a couple of weeks, all the holes are cleared up from the trash. You do another sonar scan from the surface and can see the holes clearer than before. But you still don't have an answer for this. You do some more research trying to see if any other holes appeared around the world. On the other side of the country is a mysterious blue hole off of Florida's Gulf Coast. You catch the nearest flight to Florida and make an appointment with the scientist in charge of the expedition. Blue holes are underwater sinkholes that open below the seabed. Just like on the surface, the underwater world also has sinkholes. This one is called the Green Banana and is 150 feet below, and the hole is 435 feet deep. You dive with some special gear with the rest of the team to a barren ocean floor, and the hole is right there in front of you, looking like an oasis in the desert. You and the rest of the scientists are surprised by the diverse marine life dwelling within. Some sea turtles swim past you, and even sharks. These ones don't harm humans. Halfway through, you reach a narrow path, which makes it difficult for humans to pass through. But everyone is careful. There are corals, sponges, mollusks around the corner. You collect some samples and go back to the lab. Blue holes in general are richer in nutrients than barren lands and host plenty of unique marine life. They're quite common and don't pose any sort of threat to anyone. After making the connections, you don't think the holes off the coast of California have anything to do with blue holes. The mystery goes on. For hundreds of years, people in the US have reported hearing strange, loud booms. These mysterious sounds are called skyquakes. And yep, it's a real thing. If you've ever heard a loud, distant booming noise that definitely wasn't a thunderstorm or a car engine backfire, congrats, it looks like you've experienced a skyquake yourself. People report them all around the globe, from the US to India and Japan. They go under different names, and we still don't know why exactly they happen. Sometimes these booms come together with earthquakes. People heard them during the New Madrid earthquakes in the early 19th century and up until January 2020. Those who've experienced them describe skyquakes as a rushing or rolling noise. Famous American writer James Fenimore Cooper described it more poetically as the lake speaking to the surrounding hills, which send back the echoes of its voice in accurate reply. Sometimes these mysterious booms happen in cold weather instead of during earthquakes. One of the skyquake hotspots is near Lake Seneca in New York. They call them the Seneca guns. The booms can be so loud that they shake windows and doors. Back in August 1886, after an earthquake in Charleston, people heard these noises for several weeks, happening at the same time as many aftershocks from the earthquake. In 2020, scientists from the University of North Carolina looked at old news pieces, especially from North Carolina, where people have often reported these sounds. They hoped to match the noises with earthquakes data, but they didn't find any link between the sounds and earthquakes. One of the researchers said they believe the noises are happening in the air, not underground. The team looked at infrasounds, which are low-frequency noises that humans can't hear. They found signals lasting 1 to 10 seconds that match the times when people reported hearing the booms, but nothing is certain here. Some people think that solar flares, underwater tsunamis, or caves collapsing under the sea cause skyquakes. Others believe the sounds come from planes making loud sonic booms. But that doesn't explain old records of skyquakes from the past before planes were even invented. Some scientists think a type of meteor called a bolide causes these booms. These meteors blow up when they hit Earth's atmosphere. If this happened above thick clouds, the sound would get louder and travel far, but we wouldn't find anything on the ground. Another idea is that gas might be escaping from the bottom of deep lakes, like Lake Seneca. If you think skyquakes are bizarre, let me introduce you to fog bows. They also go under the name of white rainbows, ghost rainbows, or cloud bows. They form in a similar way to regular colorful rainbows, but are much wider. Rainbows happen when there are big raindrops in the sky, and you can always spot them on the opposite side of where the sun is shining. Fog bows are made by tiny droplets in fog, or clouds, instead of big raindrops, and they also appear opposite the sun. If you want to see a fog bow, you need to look for it in a thin fog when the sun is bright. You might catch one when the sun starts to shine through the fog, or if you're near the ocean where fog often forms. Because the water droplets in fog are so tiny, fog bows don't have bright colors like rainbows. They might even look all white, or just have faint colors. Some fog bows are hard to see at first, because they blend into the mist. But once you spot them, they're easy to recognize. The next rare weather phenomenon you gotta watch out for is thunder snow. You guessed it right. It's a special type of thunderstorm that happens during a snowstorm. Unlike regular thunderstorms that often strike in the spring and summer, thunder snow is much rarer because it happens in the strongest winter storms, like big blizzards, and at the same time needs warm air, which isn't a frequent combo. So, for thunder snow to happen, there needs to be moisture in the air, some instability, and something to lift the air, like rising winds. Just like in normal thunderstorms, lightning can appear when you hear thunder. Thunder snow lightning usually goes from cloud to cloud instead of hitting the ground, and the thunder sounds different too, more like a low rumble instead of a loud boom, because the snow muffles the sound. You aren't so likely to get struck by it, but it's still important to stay inside when you hear thunder to stay safe. Northern Lights fans, this one is for you. Scientists noticed a new kind of glow in the sky that looked like a purple streak. They nicknamed it Steve as a joke, but later gave it a more scientific name: Strong Thermal Emission Velocity Enhancement, Steve for short. Steve is actually a fast-moving stream of super hot gas that always moves west and only shows up before midnight. They wondered if something like Steve could happen after midnight, but moving in the opposite direction. And now, scientists think they found the anti-Steve by looking at data from a research station in Norway. In December 2021, they took a picture of a bright purple streak stretching for 620 miles in the sky, and it only appeared after midnight. Satellites from the European Space Agency also measured the conditions in this part of the sky and found that the ions were moving eastward. Steve's late-night twin hasn't been officially named yet, but it would be cool if it was called Sam, which is short for Steve after midnight. If you've ever seen snow on a sunny day when falling from the sky without a single cloud, it must have been diamond dust. It's a special kind of weather with millions of tiny ice crystals forming close to the ground. These ice crystals float slowly in the air, kind of like how dust floats in your house. When sunlight hits these crystals, they sparkle like diamonds. Unlike regular snow, diamond dust can fall from a cloudless sky, which is why they sometimes call it clear sky precipitation. It happens because of temperature inversion. Normally, it gets colder as you go higher up from the ground. But in a temperature inversion, the cold air stays near the ground, and warmer air sits above it. The warm air has more water vapor, and when it mixes with cold air near the ground, it turns directly into ice crystals, and diamond dust is born. For this to happen, the air near the ground has to be really, really cold, way below freezing temperature. Diamond dust can fall for days, but it's so light that it usually doesn't pile up on the ground like regular snow. A fall streak hole, also known as a hole punch cloud, is next on our list. This big circular or oval-shaped gap sometimes appears in certain clouds. These types of clouds float high up in the sky and are often made of tiny water droplets that are colder than freezing, but they haven't frozen yet. These special water droplets are called supercooled, and they need a reason to freeze. Ice crystals give them that reason. When a plane flies through the cloud, it can bring those ice crystals into the cloud. Once the ice crystals are there, the supercooled water droplets freeze quickly, get bigger, and start to fall from the ground. This creates a hole in the cloud, and as more nearby droplets freeze, the hole gets bigger and spreads outward. Any tornado is scary, but a fire tornado takes the horror to a new level. These bad boys are spinning towers of flame and ash that form when there's extreme heat, strong winds, and uneven ground. The intense heat from the fire causes hot air to rise quickly. Cooler air from the sides rushes in to replace it and creates strong winds. When winds from different directions meet, it makes the fire spin like a tornado. It gets stronger and can even create its own weather. It pulls in flames, ash, dirt, and anything in its path. The winds can reach speeds of over 140 miles per hour, and these fire tornadoes can last for more than 20 minutes.
The strongest earthquake ever to strike east of the Mississippi River that happened over 200 years ago was never over, according to some scientists. Most earthquakes last seconds to minutes, and the official record breaker so far is a silent one in Sumatra that was going on for 32 years. This slow slip event triggered a massive quake and a tsunami. So if it's true that the new Madrid earthquake is still sending aftershocks, we'll have a new top name for this sad list. The earthquake started in December of 1811 with a powerful quake in a sparsely populated part of northeast Arkansas. They felt the shaking almost 1,000 miles away in the White House, and the tower bells were ringing in Boston, even further away. It even made the mighty Mississippi flow backward for a few minutes over new waterfalls formed by shifted ground. The town of New Madrid, Missouri, completely disappeared in the disaster. The Earth wouldn't stay still until the end of January the following year, when things got serious again. A massive quake hit, this time near the junction of the Ohio and Mississippi rivers, right in the Missouri boot heel. Geologists believe it was a rupture on the New Madrid Fault, putting even more strain on the nearby Reelfoot Fault. Just when people thought it couldn't get worse, another 2 weeks of trembling passed, and the Reelfoot Fault snapped deep beneath New Madrid. Down in Tennessee, about 15 miles south of New Madrid, the ground uplift created Reelfoot Lake. Steamboats were chugging along the river, with thousands of trees floating and acres of woods torn apart by the quake. In St. Louis, Missouri, which is 160 miles away, buildings were badly damaged, and chimneys fell in Cincinnati, Ohio, 400 miles away. People all the way in Montreal, Canada, over 1,000 miles away, felt the earthshake. Seismologists have registered about 200 small earthquakes in the New Madrid seismic zone every year since 1974. Some researchers believe that up to 30% of those were aftershocks from those big quakes back in 1811 and 1812. In parts of the US where there's not much tectonic action going on, these aftershocks could keep rumbling for years, maybe even centuries, after the big ones hit. Aftershocks are the Earth's way of releasing all that built-up stress from the main quake. When the ground shakes from the first earthquake, it puts a lot of pressure on the rocks nearby. And when those rocks can't take it anymore, they crack, causing even more shaking. That's the aftershock. And they can be pretty intense, especially right after the main quake, but weaken over time. Not all scientists agree that contemporary earthquakes have to do with those from 200 years ago. We mostly associate faults with those lines where Earth's plates meet. But there's a whole network of those right under the center of the North American plate. They're like relics from 750 million years ago, when North America was part of a supercontinent called Rodinia. When Rodinia started to break up, it left behind these rifts, weak spots in the Earth's crust that run deep beneath the modern Midwest. It could explain the earthquake action. An international team of geologists decided to take a fresh look at 3 major earthquakes that shook North America and end the debate. They used a new math method called the nearest neighbor. It says that if earthquakes are too close in space, time, and magnitude to be independent background events, then one is assumed to have triggered the other. Depending on how you look at the numbers, somewhere between 10 to 65% of the recent quakes in the region could be aftershocks of those historic earthquakes. And a huge quake that hit Charleston, South Carolina at the end of the 19th century might explain up to 72% of the earthquakes in the area since then. But not all places are the same, so the scientific debate continues. In 1774, British explorer James Cook noticed a glow in the distance. It was the volcano of Mount Yasur in Vanuatu. This bad boy had been spewing lava and ash ever since, and it's quite likely that it's been doing that for way longer. The volcano has been sitting at alert level since October 2016, which means things are really unsettled around there. They've even marked off a 2,000-foot radius around the crater to keep people safe. There have been low to moderate outbursts, shooting out ash, gas, and steam, and some bigger blasts throwing stuff outside the crater. Satellite images have picked up on some hotspots of sulfur dioxide plumes, showing that Yasur is still cooking up a big storm down there. Stromboli, one of the volcanic islands near Sicily, officially has the Guinness World Record as the longest continuously erupting volcano. It has been putting on a fiery show for over 2,400 years straight. Ancient sailors nicknamed it the Lighthouse of the Mediterranean. Most of the time, Stromboli's just spitting out spatter, but every now and then it throws in some lava flows or shoots up some moderately high fountains. Sometimes you might even catch a glimpse of steam-driven outbursts. Over 200 million years ago, the world went through a major makeover, with not one, not two, but 4 massive volcanic eruptions changing the game. It all happened in Rensselaer, a large chunk of island that used to be a supermassive volcano stretching across what's now British Columbia and Alaska. This volcanic activity might have helped dinosaurs grow from cat-sized critters into giants we saw in Jurassic Park. It kicked off a 2-million-year rainy season. It made the whole world hot and humid, and the dinos just loved it. Researchers dug deep into sediment layers beneath an ancient lake in China to uncover these secrets. They found traces of volcanic ash and mercury, clear signs of those epic eruptions. There were carbon signatures showing huge spikes in carbon dioxide levels, making the atmosphere toasty and the rain pouring down. It all happened in 4 separate pulses, each triggered by those monstrous volcanic blasts. There's a spot in a national park not too far away from Sydney, Australia, where a fire has been raging deep underground for at least 6,000 years. They call it Burning Mountain, and it's a coal seam fire, burning its way through a layer of coal beneath the Earth's surface. Once these underground fires start, they're pretty much impossible to put out. This ball of fire is up to 30 feet wide and extremely hot, but there's no flame, it's smoldering. The fire has been creeping along at a pace of about 3 feet per year. A local farmer first spotted it in the 19th century and thought it was a volcano. The people who have lived here for ages believe this place is sacred. They've used it for cooking and crafting tools, and tell that it started from a widow's tears or the torch of a hero. But experts think it could have been a lightning strike or coal heating up like a summer barbecue from the interaction with oxygen. Some say it might have been burning since before the dinosaurs roamed the Earth. No one knows exactly how long this mountain will burn or in what direction it'll move. Right now, the coal has enough oxygen to burn for centuries or even millennia without human intervention. The fire is heating up the mountain like a giant oven, making it crack and crumble, inviting in more oxygen to feed on. Even if humans decide to take action, these coal-seam fires need truckloads of water and liquid nitrogen to tame them. Several years ago, explorers noticed that the smolder was creeping close to a cliff overlooking a little river. And depending on what the coal seam decides to do next, we could see some dramatic changes here in the coming decades. There could be flames with much more heat, or the coal seam could go deep, extinguish itself, and smolder out. Okay, it's pop quiz time. What's the strongest river in the world? The Amazon? Pfft, rookie guess. No, really. The mightiest river isn't on land at all. It's underwater, and is called the Antarctic Circumpolar Current, or ACC for friends. This beast flows with a force 100 times stronger than the Amazon River, and it could power over 100,000 hydroelectric plants. That's enough electricity to light up entire continents. But this underwater juggernaut doesn't just flex its muscles for fun. It's the planet's ultimate multitasker. The ACC is Earth's thermostat, carbon vacuum, climate stabilizer, and oceanic superhighway all rolled into one. But here's the not-so-fun part. Scientists have spotted a serious red flag. The ACC is slowing down. And not just by a little bit. We're talking up to 20% weaker by 2050. If this trend continues, we're looking at climate chaos that could make your worst Monday feel like a day at the spa. So, maybe time to panic a little? Well, hold on. So what is the ACC anyways? To learn more about it, we need to dive deep into the ocean, figuratively. The Antarctic Circumpolar Current is the only ocean current that flows all the way around the planet, hugging the cold continent of Antarctica like a belt of water. Unlike other currents that get tripped up by continents, the ACC has a clear racetrack, nothing but open ocean, so it flows uninterrupted through the Drake Passage between South America and Antarctica. It moves an astonishing 3.6 billion cubic feet of water per second. That's so much water we couldn't find anything to compare it to, sorry. The ACC is driven by ferocious westerly winds, moving eastward to connect the Atlantic, Pacific, and Indian Oceans into one continuous supercurrent. It also plunges into abyssal depths, connecting shallow, intermediate, and deep waters into one giant, swirling blender of oceanic energy. Now, to put it simply, it may be too late for that, but I'll try. The ACC is the glue that is keeping all of our planet together. It plays a starring role in the thermohaline circulation, or global conveyor belt, if you don't want to sound lame. This is the system that redistributes heat, carbon, and nutrients around the globe. To make it all work, the ACC pushes nutrient-rich deep water to the surface in a process called upwelling, feeding plankton, krill, whales, and eventually sushi on your plate. That means if you love seafood or care about ocean food chains at all, you should really start paying attention. Without this nutrient cycling, marine life from the bottom to the top of the food web suffers. Now, here's the cool part. While it's busy playing waiter to the sea, the ACC is also doing our laundry. Well, sort of. It absorbs massive amounts of carbon dioxide from the atmosphere and stores it in the deep ocean, locking it away for centuries. Think of it like Earth's giant carbon vault, no password required. It also helps regulate the weather. Without the ACC pushing heat around the globe, Western Europe would be 50 degrees colder. That means Paris would feel like Siberia, and Londoners would have to trade their umbrellas for snowshoes. The current helps maintain the temperature balance between the hemispheres, stabilizing wind patterns, rainfall, and ocean temperatures around the world. Even hurricane patterns could change because warm ocean surfaces are a key ingredient for cyclone formation. Mess with the currents, and you might be dialing up stronger, weirder storms. So, why is it slowing down? Well, of course, the answer is humans. You know those ice caps that are melting? Well, in Antarctica, where our friend the ACC lives, there's so much ice that if all of it melted, the Earth would rise more than 200 feet. That's taller than Cinderella's castle. What's worse, 60% of all the fresh water in the world is frozen in that ice. While that much water melting is already terrifying, it's the freshness of the water that really messes things up. You see, the ACC relies on the Southern Ocean's cold, salty water to be dense and heavy so it can sink, which helps power the current forward like a chain reaction. But when fresh water from melting glaciers pours into the ocean, it dilutes the saltiness. That makes the water less dense, so it stops sinking properly. Without that sink and flush mechanism, the ACC can't maintain its powerful flow. It's like trying to flush a toilet with no gravity. As this continues, fresh water flows north, altering the ocean's density structure and counteracting the effects of ocean warming, which normally would speed the current up. Instead, the ACC slows down. A weaker ACC means less upwelling, so fewer nutrients reach the surface. This could devastate Antarctic marine ecosystems, reducing biodiversity, collapsing fisheries, and threatening species like penguins, whales, and krill. It also opens the door in Antarctica to invasive species, like the southern bull kelp, which could throw entire food chains into chaos. Krill alone are the main food source for whales, seals, penguins, and fish. So when krill populations crash, the whole system begins to wobble like a house of cards in a hurricane. And then there's the feedback loop from hell. As the ACC weakens, more warm water can sneak southward, reaching Antarctica and melting the ice even faster. That melting will dump more fresh water into the ocean, which will weaken the current even more, which will melt more ice, and you get the idea. It's a vicious cycle. Worse still, warm waters underneath ice shelves can cause them to break apart from below, meaning the melting accelerates even when surface temperatures seem stable. Globally, the effects would ripple far and wide. Monsoons in India could become erratic, rainfall in the Amazon could drop, and agriculture from Africa to Asia could suffer. Sea levels along the east coast of North America could surge, and global weather patterns could spin into confusion. Even the Southern Ocean's ability to support commercial fisheries, like Chile's lucrative salmon industry, could decline as nutrients fail to reach the surface. And let's not forget, without a strong ACC, the ocean's ability to absorb carbon and excess heat plummets. That means that more CO2 and heat will stay in the atmosphere, making our lives even more miserable. It's like turning off Earth's air conditioner while cranking up the furnace, and burning down the pantry while you're at it. Of course, this isn't the first time things went south with the ocean currents. Before humans started heating up the planet, Earth went through a deep freeze called the Little Ice Age, and it wasn't just about colder winters. This icy chapter may have kicked off when ocean currents in the North Atlantic started acting weird. And it wasn't so long ago. This Little Ice Age had a peak in 1850, literally yesterday. Scientists believe that melting glaciers and massive exports of Arctic sea ice flooded the ocean with fresh water. That fresh water messed with the ocean's usual saltiness and density, weakening powerful systems like the AMOC, short for Atlantic Meridional Overturning Circulation. That's a mouthful. It's another crucial piece of the global conveyor belt puzzle. As these currents slowed down, less warm water reached the north, sea ice spread farther, and temperatures dropped even more. And here's the spooky part. Records from seashells near Iceland show that this shift didn't happen all at once. It came in two waves, like the planet was struggling to stay stable before tipping into a colder world. And because the AMOC is also part of the crazy life support system of planet Earth, everything is connected. Both systems are influenced by temperature, salinity, and the sinking of cold water. When the ACC slows, it can alter the balance of deep water formation and mixing, potentially weakening the AMOC too. That's a domino effect you really don't want to see. In fact, some models suggest that if both the ACC and AMOC are pushed past their tipping points, the result could be centuries of unstable climate conditions, way beyond anything modern agriculture or infrastructure is built to handle. So, next time you're sipping a cold drink or enjoying sushi, maybe raise a toast to the mighty ACC. It's doing a lot more for you than you think, and it could really use a little appreciation and less ice melting, please. In the UK, there are around 115,000 mailboxes, with some of them placed in questionable locations. Look here, we're on a deserted stretch of Caithness Moorhead, and here, just smack dab in the middle of nowhere, between the quarry and some moorland, stands a solitary mailbox. It was local teacher Chris Aitken who stumbled upon this oddity near Worth Hill, close to John O'Groats. Now, John O'Groats is a tiny village 2.5 miles northeast of Canisbay, in the historic county of Caithness, Scotland. The village itself is popular with tourists, but only houses around 300 people on a regular basis, and they have their own mailboxes there. So why would someone need one on a random hill? When Chris shared a photo online, someone chimed in with a theory. A while back, an entrepreneur was selling tiny parcels of land near Campster, claiming buyers became lairds with their little plots. Could this mailbox be related to that? Now, the box, proudly labeled Laird of John O'Groats, features the name Thorsten Sommer and an address in Germany. There's a PIN number on the front, but when Chris opened it, all he found was a website link. The site has pics of Sommer waving a Scottish flag and talking about his love for Scotland, even calling himself the Old Scotsman. Chris tried reaching out through the website for more info, but hasn't heard back. It might be linked to Sommer's reported purchase of a tiny patch of land, but buying Scottish laird titles is often seen as a fraud, giving no real title at all. The area around Worth Hill has had some recent police action too, after a body was found nearby. Ooh, could that somehow be connected to this mysterious mailbox too? Well, enough of the detective stories. Let's dive into some high-end fashion, shall we? So, you might have come across that funky image popping up all over the internet, claiming there's a pop-up Prada store in the Texas desert. Well, it's kind of true and kind of not. Yes, there's a shop, sort of. It showcased a whole range of Prada gear worth around $80,000. And guess what? Miuccia Prada herself handpicked the items. But still, you couldn't buy a single thing there. No cashiers, no shop assistants. It was like the place was permanently closed. The twist? It's actually an art installation. Made entirely of biodegradable materials, it was designed to gradually blend back into nature, taking a fun jab at our current consumer culture. But why display goods you can't actually buy? Well, it's a metaphor for the elusive charm of luxury. While it was meant to decay in peace, the hype surrounding it led to a surprising amount of foot traffic and even some chaos. After trying to fend off a few would-be thieves, the artist had to admit defeat. Now it's a hotspot for photos, drawing everyone from tourists to celebrities. Right, you can find a brand purse in the desert, but can you, let's say, find a car somewhere in Welsh caves? Well, the answer is yes, and let me tell you, it's not just one car, but many of them. The Cavern of Lost Souls is a well-known abandoned car cave tucked away in Wales. Once upon a time, it was a slate mine in Ceredigion, where workers pulled out tons of slate and transported it using narrow-gauge horse-drawn tramways. But as the mining industry faded away decades ago, the mine fell into a hush. If you dare go inside, which I personally do not recommend, you'll find two large chambers, but one is particularly noteworthy. The main chamber plunges around 65 feet deep and is mostly underwater, with just a small opening above. Since the mine shut down, locals and the council have taken advantage of that opening, tossing in all sorts of unwanted stuff. You'll find everything from fridges and TVs to even whole cars piled up in one corner. What makes the Cavern of Lost Souls special is the single beam of light that breaks through, casting its glow on the twisted heap of wrecked cars and metal. The water, when hit by that light, glows a stunning turquoise green, creating beautiful reflections of the cars and cavern walls on the still surface. Every now and then, a fragment of slate falls, shattering the quiet and sending ripples across the water. There was yet another weird find in Wales. A shiny 10-foot silver monolith recently popped up on Hay Bluff in Powys, Wales, and it's sparking a ton of curiosity. A local builder, Craig Muir, discovered it during his hike, and he described it as looking like it just dropped down from space. It's made of surgical steel, has no markings, and is super well crafted without visible welds. Muir's find is reminiscent of those mysterious monoliths that popped up worldwide in 2020, creating quite a buzz online. Local Richard Haynes suggested it could be some kind of scientific installation, but with national park rules against unauthorized structures, it might not be there for long. With no visible tracks around it, Muir speculated it could have been brought in by a group or even dropped from a helicopter. Now, this isn't the first strange monolith sighting. Similar ones have been spotted in Utah, the Isle of Wight, and even Glastonbury Tor, where one was humorously marked "Not Banksy." However, it could be easily him. The UK is the leading country in terms of the number of Banksy's pieces of art. As of 2023, there were 70 of them. No wonder, as he is reportedly British and was born in Bristol. The Atacama Desert in northern Chile, the driest non-polar desert on Earth, features a bizarre sight at kilometer mark 1309 on the Pan American Highway, a giant cement hand that towers 36 feet above the sand. Looks creepy, right? Well, worry not. It's not some creepy monster trying to grip you and take you to the netherworld. It's not an ancient relic from a lost civilization either. A professional sculptor created this quirky landmark back in 1992. Despite its remoteness, the hand is frequently targeted by graffiti, so local volunteers must clean it up twice a year. And by the way, it's not the only landmark of this kind. The very same sculptor also created a similar hand in Punta del Este, Uruguay, called Man Emerging to Life, and it represents the idea that a giant might be holding South America in a stone grip. Hey, works for me. Now check out this giant stone sphere hidden in the forest of Bosnia's Visoko Valley. What do you think? Is it an ancient relic or a modern art installation? Share your thoughts in the comments. But to be completely frank with you, which I always am, nobody really knows for sure. Experts think this sphere, which measures around 10 feet across, is just a naturally occurring rock formation called a concretion. These iron-rich balls get their reddish color from the high iron content and form when mineral particles stick together over time. While concretions can take on some pretty wild shapes, the exact process of how they form is still a bit of a mystery. Then there's this archaeologist, often called the Bosnian Indiana Jones, who claims it's actually a man-made artifact from over 1,000 years ago. Spherical concretions aren't unique to Bosnia, though. You can find them all over the world, like these boulders in New Zealand, massive round stones that are over 60 million years old. There are also cannonball concretions in North Dakota. And let's not forget about the man-made stone spheres crafted by the Diquis people in Costa Rica, which are perfectly shaped and arranged, definitely a testament to human creativity. So while the Bosnian sphere is super intriguing, it's probably just an ancient concretion and not a remnant of a lost civilization. Bummer. Finally, some things are so well hidden that you have to go deep down into the seafloor to get a glimpse of them. Once a hedonistic hotspot for the Roman elite, Baia was like the Las Vegas of its time, but now its ruins are submerged underwater. This resort city thrived on volcanic hot springs and attracted the likes of Nero and Caesar, who even built vacation villas there. However, in the 8th century, Baia lost a battle and was abandoned by 1500. As the water levels rose, much of the city was lost beneath the bay. Today, you can explore Baia's ancient ruins in one of the few underwater archaeological